So to be sure, I have to connect also here. Yeah. Okay. So now that we know about vectors, second thing to do is, yeah, I want to also ask to know about matrices. And then, yeah, if you know about matrices, since we are going to deal with 1D and 2D only, I will just dodge arrays, but you can still go to the web page to know more about arrays. And then we discuss lists and data frames. Oui, il faut me rappeler le soir. Je suis occupé maintenant. So now when we read the data frames, this is where we are going to import data from external sources. So this morning or yesterday night, we shared a set of data with you. So when we read data frames, we'll be able now to load them in the system and then do the now data analytics. So we clean the data and then we come with visualizations. So probably afternoon, okay? Yeah. So now what's a matrix? So matrices, who knows what is a matrix? What's a matrix? How many dimensions does a matrix have? 2 dimensions. Yeah, so it's also a tabular with what? Rows and columns, yeah? So now the question is, how do you define a matrix? So the answer is we use the matrix function, okay? This is a function. So, sir, you will remind me the question later. Yesterday, someone told me, what if you want to put like percentages in parentheses and so and so. So, yeah, we will reach when we'll be doing like thorough data analysis. Okay. So first of all, we can also define a matrix. Define a matrix from a vector. So you already know what is a vector, right? So if you have a vector v is equal to 1 to 9. So 1 to 9 will give you a vector of consecutive numbers from 1 to 9. And you know that it's also the same as having a sequence from 1 to 9 by what? By 1. Yeah? Yes. So to 1, you add 1, it will be 2. With 2 you add 1, it will be 3 until you reach 9. This is what it sequence does. If you want, you can run this. See, 1 to 9. Or you can run this, is the same thing. 1 to 9. Hmm? Yeah, yeah. But now if you do by 1.5, no, lesser. You see, 1.1, you start from 1, and then to 1 you add 1.5. So it will be 2.5, 4, 5. Actually, this is the window. We call it window. Mhm. So now from this vector, you can choose any vectors. I just chose this one just for simplicity, yeah? Making things simple. So now you can now use our matrix. So M is equal to, so you use the function matrix, and using V, we can create a matrix. Okay. Now you see that when you put a comma, just like in Excel, you see those arguments, possible arguments you can input. Now by default, yes, please. Huh? Come again?
I tried to run, but it doesn't show. Because it didn't print it.
Oh, okay. What I do, see, if you run like this, nothing is going to happen because you are saving 1 to 9 in V. You see no result. But if you want to see the exact thing this value is doing, you select only that part like this, and then you do Control Enter. Even a part, like even if it is commented, you can select this, and then it will still run in R, like this one runs. Okay, yeah. So if I want to create a 3 by 3 matrix from those 9 numbers, okay, a 3 by 3, so it means how many columns do I need and how many rows? I already gave you the answer. But yeah, 3 and 3. So number of rows. So the argument is number of row, n row. Okay, is 3. And now R is able also to detect, when you provide the number of rows, it is not necessary to even provide the number of columns, because R will determine the total number of elements in V and guess the number of columns directly. So it's not a must to provide the number of columns. So this is a matrix. Actually, you see, you have 3 rows and 3 columns. Hmm? Yeah, yeah, good. Yeah. So you see, but now by default, it is aligning by column. You see, 1, 2, 3. Those are the first numbers, right? Followed by 4, 5, 6, 7, 8, 9. So if you want 1, 2, 3, 4, 5, 6 to appear row wise, there is another argument we call. Yes, please.
What does it mean practically?
What does it mean practically? I will give you an example. Yeah, I will give you an example. Then you will relate. Have you ever heard about the system d'équation?
Yeah.
Yeah, we are going to solve one using R. Système d'équation à plusieurs inconnus.
À plusieurs inconnus.
Oui, oui,
Équation à plusieurs inconnus.
oui. We can use matrices to solve that problem. Yeah. And in machine learning, we always, turn data into a matrix, and then we do matrix operations to get Yeah, this is also one of the examples if you want. Yeah. So if you want the alignment instead of by column, it if you want it to be by row, so there's an argument called by row, and then you turn it into true. By default, this argument is false. All right. So now if you run and you print m, you see now before it was 1, 2, 3. Since by row is true, now you have 1, 2, 3 like this. Okay. So I'm going to change this one into M1, matrix 1, and then I'll also create an M2. Hmm? You are running everything. Click on. Hmm. I think those are capital G's. You see, the caps lock is. So turn them all in small G's, even up, up. Yeah. Mm-hmm. Mm-hmm. Hey, by row shouldn't should be bind. No space. Yeah. Good. So you can print them if you want. So we have two matrices, M1 and M2. So M1 is, we turn the V into a 3 by 3 matrix, and the alignment is by row, and the second one alignment is by column, as you can see. 1, 2, 3 is here. This is by column, and this is by row. By row through 1, 2, 3, 4, 5, 6. So now we can also do matrix operations. So can we continue? Can we continue? All right. So having two matrices M1 and M2 as displayed. So you can have any other example. So we can be able to add matrices, all right? So adding two matrices is just, is M1 plus M2. Just like this. Okay, and in R it work this it is working the same. So you just type M1 plus M2. Is it true?
Sorry,
Mm-hmm.
I have a question.
Yes.
Why do you put US dollar symbol?
This one is called late LaTeX. I just want you to visualize things. Hmm? This LaTeX, I showed you the document I generated yesterday, the article. Yeah, yeah. This is how we write mathematics in that document. So it's not an R code, it's just to display mathematics. I can display anything else. Like if I want to show you, yeah, if I want to say, okay, given a vector, if you want to calculate, for instance, the average. So I can write things like this: sum I goes from 1 to n of xi. This is how we write the mathematics for the mean. It's just mathematics. Okay? Yeah. Yeah. So can you test? Let me give you, use whatever knowledge you have. Test if m1 plus m1 is equal to 2 times m1. Is it true? If you have a matrix M, so if you add it to itself, does it give us 2 times that matrix? Hmm? Why? You have to test. You know how to test, right? You forgot this one? Is it equal to 2 times m1? Hmm? Yeah. So it is testing element by element, and you have a matrix of booleans. It's true, true, true. Yeah. So it means that the elements of this sum are equal to the elements of the right hand side. Hmm? So the real question is, where do we use matrices? We use them everywhere. Okay, use them everywhere. Even a data frame is a matrix. Yeah. Why is it not showing? What did I just do? Uh, oh, okay, okay. Hmm. So if you have so just for you to know matrix operations little quick before we write them. So we have m1, right? 1 2 3 4 5 6 7 8 9, and m2 is equal to what? 1 2 3 4 5 6 7 8 9. So the m1 plus m2 we had, it's just an element by element addition, right? So this one, you add this one, take this one, you add it to this one. So 1 plus 1. And then you take this 4, you add it to this 2. It's 4 plus 2. And this, and so and so. Yeah. If it is uh if it is subtraction, m1 minus m1 m2, the same thing. It will be 1 minus 1, 4 minus 2, 7 minus 3, and so and so. Okay, isn't it? And now if it is multiplication, so this is the trickiest part, huh? So multiplication, so if you have m1 m2, what do you do? Hmm? Yeah, so you take the first row, of the matrix like this, and then you do multiplication element by element by the first column of that matrix. Okay, Element by element is what? You do 1 times 1 plus what? Yeah, 4 times 2 plus 7 times 3. And then you calculate, this is what is going to be put here. For the second element, you also take second row and first column is still, okay? And then you do the same thing. 1 times, no, 4. Yeah, means you are following is good. 4 times what? 1 plus 5 times 2 plus what? 6 some 3. And then you, if you finish calculating it, you put it here. And then you take the third column and then you do it first column again. It will be what? 7 times 1 plus uh-huh 3. And then you calculate and you put it here. And so and so. Now you move to first row again. Now second column. And then you put the answer somewhere here and then so and so. And in R, we just use this function M1, M2 to make the matrix multiplication straightforward. Okay? Is that okay? Yeah. So for the subtraction, if I do M2 minus M2, what will be the answer? 0, 0. Only 2 zeros. 9 times. So you have a null matrix with all elements equal to 0. So it is an element by element subtraction. So, okay. It's just M2 minus M2. It's just like X minus X. It is 0. No. I just wanted you to do M2 minus M2 so that you can get zeros everywhere. Yeah. Hmm. Hmm? Yes. Good. Yeah. Now matrix multiplication, if you do M1, now this is the operator for matrix multiplication. If you use that star, it will be doing element by element. But for matrices, matrix multiplication is this symbol. Okay. Yeah. And you can verify if you want. Okay. So can we divide matrices? The mathematicians say yes, we can divide. So, but if you want to divide, you don't use this slash operator. We don't do that. Okay. It's divide. Yes. Yes, we can. Yes, please open your microphone and ask your question.
Yes, I have a question about the matrices multiplication. What if we don't use those percentage sign?
Yeah. So if you don't use the percentage, if you just use the star, the normal operator for multiplication, it is going to do like an element by element. So element by element means what? What is yeah. So you have this multiplied by this multiplied by this, and this multiplied by this in the result. So if you want the first row, yeah, someone asked a question. Yeah. So so the first row you have one times one, and then 2 times 4, which is 8, and the 3 times 7, which is 21. So this is what happens here: 1, 8, and 21. And does it? Do you see?
Yes, I can see it.
Yeah. This is just an element-wise multiplication, and this is what we call a matrix or a dot product. Okay,
Okay.
or matrix multiplication. Okay.
Yeah, it's okay.
Okay. All right. So if you want to, like, let's say, divide a by or m1 by m2, this is not how we write it. Normally, in matrix operations, we multiply m1, so we multiply, so matrix multiplication by the inverse. Okay, the inverse of m2. So let me write it in mathematical form. So inverse is just, so we have this minus 1. Mm, Why is the formula not responding? Okay, so m1 divided by m2, in algebra, it implies that you have to multiply m1 by the inverse of m2. Okay, so now the question is, how do we get the inverse of a matrix in R? Yeah, don't worry, it's very simple. So to get the inverse of a matrix, we use the function. That function is named solve function. So if you want to solve m2, so gives the inverse of the matrix m2. Now you see the error here is saying that the matrix Yeah, it's singular. Means that we have vectors that are not independent. This is linear algebra. For you to get a z, so it means that the determinant, even the determinant of the matrix is 0 actually. Okay, the determinant of M2 is 0. That's why you cannot get the inverse of M2. Mathematicians can relate. Yeah. If the determinant of a matrix is 0, means that some vectors are linked. So if some vectors are linked, then you cannot have the inverse of that matrix. Yeah. Yes. So let's now, since we cannot have the inverse of this matrix, let's let's construct other examples. We have, so I'm going to construct matrix A, which is equal to, So we have a new matrix. So yeah, taken from one example we are going to use. Okay. So what is this, guys? What is this? It's a vector. Yeah. So instead of putting the vector outside, we can directly put it in the matrix function. Okay. So let me know when you are done with the matrix. And then, so if we divide a matrix by itself, mathematicians, dividing a matrix by itself gives us what? Huh? No, not singular. One, that's one like this. No, don't say. A matrix divided by itself. Identity matrix. Yes. Yeah. Okay. So calculate the matrix, the inverse of A. You know the function, right? What is the function? Solve. Yeah. So let's use solve function. This is the inverse of A. And why do we get the inverse calculated? Why don't we have like an error message, but we have the inverse calculated? So you can verify the determinant. Okay. Yeah. Determinant is not zero. So the determinant here is 3. That's why you are able to calculate the inverse of A. Okay. Can I assign this result to another matrix? Is it possible to assign this one to another matrix? Yes, right? So we can call this one a matrix B. Or you can call it A inverse. A inverse, like this. isn't it? Now, what is A divided by A? If you are using matrix operations. Hmm? This is the same as what? A times inverse of A. Yeah. So it's not an implication, but I think it is equivalence. Equivalence. Yeah. And what is A inverse? The one we calculated. Yeah. So we can create another chunk to now make things happen. So A, what is the operator we use for matrix multiplication? This one. And then A inverse. And this is the result. So this is a 0. This is also a 0. This is a 0. This is a 0. Huh? So if to see it, just do round. Round the results. This is the identity matrix you are looking for. Hmm? Yeah. So if you divide a matrix by itself, this is like a 1 in terms of matrix. This is the 1. When we are doing matrix operations, this is equivalent to the 1 of matrices. Huh? It's linear algebra, actually. Yeah. Yeah. Yes. Okay. Now that we have all ingredients, there is something that you don't know. It's matrix transposition. Hmm? All those things we will use them later. Okay, we can transpose matrices. Hmm? So transposing a matrix is just like turning rows into columns. Just turning the matrix like this. Hmm? So you just use the T function. So T of A is the transpose of A. Hmm? Can you see the difference? This is A. So the first row of A has become the first column of the transpose of A. Second row becomes the second column, so and so. Hmm? Then there is determinant. You already know it, determinant of A. We found 3. Determinant, yes, it's A. So examples, urachire. Hmm? Hmm? Am I moving fast? Are you together? Hmm? Hmm? This one? Okay, okay. Hmm? C'est bon, c'est fini? Vous êtes à quel niveau? Ici? Ah, vous pouvez toujours faire hein, ici. Ouais. Faut toujours me stopper. J'ai tendance à aller vite. Stoppez-moi. C'est bon? Ça peut aller? C'est bon? Ok. So, par exemple, on peut. Qu'est-ce qui s'est passé? Mhm. Voilà. Ah, ah, transposition, ok. Hmm.
And the determinant is like the statistics, determinant functions
Yeah.
of area locality, like that.
Uh-uh. No, no, no. Determinant is in linear algebra still. Is when you have, hmm? Hmm? Yeah? Like determinant d'une matrice. So yeah, this is the equation we are going to solve. Okay. And when you have a matrix, let me just take a 2 by 2 matrix. Like if you have a matrix like this, 2, 1, 0, and maybe -1. Yeah. If you have a matrix like this, so determinant of A, the, yeah, is this one. Yeah. So you do this multiplied by this minus this multiplied by this. You remember that? Yeah. And for if it is more than 2 dimensions, you have to now, cross one, eliminate one row and one column, and then you calculate the determinant of the matrix that is remaining. You multiply by yeah, it's linear algebra. Exactly. Yeah. So like this one is 2 times 1, which is 2 minus 0. So it just this determinant is 2. Yeah. So so you're done with transpose. Yeah. Transpose is just turning rows into columns. That's it. You take the first row of the matrix and you put it as a column. So it's a good check for the invertibility of a matrix. So invertibility is mathematical word that R does not know. So I want to determine whether a matrix is invertible or not. You can use determinant. So yeah. So let's finish covering those basics. Then we'll deal with real data. C'est bon? So we can use, sorry? Determinant, okay.
For me, it doesn't.
Hmm?
The result is different from the
Is it the same matrix? A?
determinant.
Yeah.
I have a non-form.
Are you? Do you have the same numbers as mine? Like 0.52, negative 1,
Change.
Ah, okay.
Yes.
Yeah. So it's different. It should be different. Mm. Mhm. So please don't bother to type this one. Please, it will take us time for nothing. Okay. So if you want to like solve this kind of equation, you see you have like a three unknown how do you call them?
For sure.
Huh? Yeah,
Was it good?
inconnu. three unknown parameters to be solved. So we want to get the value of x, y, and z. So we can still use matrices to solve this one. Hmm? Okay. So this is just an equation of this form: a multiplied by a matrix big X is equal to b, isn't it? For those who did mathematics, I'm not excluding others. So this can be turned into to this. So what is a? Yeah. Uh-huh. She has been waiting for that moment her entire life. Well, yes. So now the matrix A is all the coefficients you can see here. Okay. And what is X now? Yeah, X now is X, Y, Z in column for the multiplication to be possible. And B 0, 0, 2. Yeah. So yeah, it is 2 here, not 0. 4. Yeah. So B now is 2, 0, 2. Okay. So now if you want to determine X using mathematics, if I want X, what should I do? Huh? Yes. Now, how do we get into the B inverse A? Let me share my screen here and then I will show you. Okay. That's really good. My economist. It's really, really nice. So I'm going to display this one. Stop sharing and I share from here. So here's the same system of equation system. So as she said, so now this could be equivalent to a system called AX is equal to B. So now with what? A equals to what? The coefficients, right? So 0 0.5, 2, mm-hmm, 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 yeah. X is equal to what? Yeah. And B, 2, 0, 2. Isn't it? Now, if you have the system AX is equal to B, you can multiply both sides by the inverse of A. So if I multiply here by A inverse, I should also multiply A by A inverse. Yeah, here, right? So what is A inverse A? It is identity. So this is equal to I. So IX is equal to, yeah. So what is identity multiplying? So identity is like a 1 in numbers. So identity multiplying any matrix So it gives you the matrix. It's like 1 multiplying x. So it's, yeah. So this is how we determine we determine x, y, z at once. Okay. Hmm? Yeah. So how do you, so if you get a, how do we get the inverse of a in R? You solve, and then you do mathematical multiplication by the right hand side, and you get the solution. Yes. So let's put it in practice. Hmm? Hmm? So mathematics made easy.
Not easy.
Uh,
Mathematician, they enjoy. For us, we are seeing stars.
really?
Sure.
Oh, okay. You are getting to data very soon. Okay.
I can't pay anything now.
So now, if you want x, y, z, so x is equal to what? You said to get the inverse of a, it's what? So, so a. Actually, it is the a that is up. If you check very well, 0.5 is the same a I gave as example. This one. So it is already in the memory. Yeah. So solve a will give us the inverse, and then we multiply it by b. B is what? 2, 0, 2. Now if you want, you can display x. Yeah. So x is equal to 2, y is equal to 1, and z is equal to 1. Okay? Yeah. That's it. But this one can take days if you have to like solve it manually. No, not days, but
C'est just une phase du cours d'équation à trois inconnues.
oui,
X, Y, Z.
oui, avec la méthode de Gauss, méthode de substitution, méthode de Kramer.
Des substitutions et des caméras.
Oui,
Ah, je-
voilà. Yeah. So now, yeah, you ask the question, now you get the evidence, right? We can use matrices. I can add another one, but it is so tough. We can do linear regression using also mathematics. Please, let's jump to something. Uh, yeah. Yeah. Mm, mm.
You hide some factors.
Mm. So please don't write this one. It's not necessary. You can write it in your notebook. This one. Yeah. Don't write this one.
That's impressive.
Hmm?
It's impressive. So what?
If you want, but it is going to take you time. Uh, if you want, you can write.
R is a big environment.
Yeah.
It's a big word.
And Python does the same thing too. So yeah, but I like R is, and all those things when you compile, they go to the Word document as they are. Mm, yeah. Hey, I have an error somewhere. I don't know. Oh, it's about the solve empty. Please wait with me. So I'm just going to say error is equal to true here to be able to compile the entire document. Yeah. Mhm. Can we continue? Où est-ce que vous êtes? Sur les équations. Ah. Ok. Mhm. Mhm.
It's too amazing.
Hmm? Is it capital C or because you know your
It's
capital?
not capital C.
Yeah, it is. Yeah. Hmm. Are we together now? Hmm? Ah, was trying to do something, it doesn't. All right. So now, let's discuss about lists. So I told you that list is a dictionary that can contain what? Any type, right, of data. Okay. So how do we define a list? It's just list like this. If you want an empty list, it's just list without anything in it. But if you want to add elements, yeah. So you can add maybe a vector. There's a question. Ah, Benjamin. Okay. Vector, you can put your V here. If you want, you can add a matrix. So you can put A here if you want to add what again? Data. So there is an inbuilt data in R called iris. Iris data. It's about flowers. These one. Okay. If I even add it here, iris. So it's a bunch of things. You put, and now if you want to display L, you see it comes with everything that you added there. You see, you added a matrix, a vector, so the vector is here, the matrix is here, so you can have any type of data stored in your list. Yeah, it's a powerful container. So when you'll be writing functions, if you want to return result into a list so that someone can just pick whatever they want, in the result, yeah, can also do so. So it's just a dictionary. So, and the names are called keys, and the right hand side are values. So that's like in Python. Yeah. Mm. So inbuilt data means that it comes with R. When you install R, R is already there. Okay, or Iris. I don't know how you pronounce it in English. Is it Iris or Iris? Iris. Yes. No, but this one is flowers. I don't know. Yeah, yeah, flowers. Iris. Yeah, there is also in French Iris. Yeah, in eyes. Yeah. Sorry. Uh-huh. Yeah, use print so that you can see everything all together. Yes. Yes. Hmm? These are data set that is already incorporated in R. Yeah, and it is the most used data set when it comes to training. You can do classifications, machine learning using that data. That's it. Hmm? Hey, your computer is producing euros. It was here. Okay. So now, how do we access an element of a list? Like now I have my list as a container, but if I want to access only the matrix A in L in my list, what should I do? I have my list, which is a container, right? And in it I have a vector V, and I have a matrix, and I have even a data frame A. So if I want to access only the matrix, hmm? Hmm? Yeah, we have many ways. Yes, we have many ways. So as you can see the dollar sign here, if I just copy the dollar sign with the vector or matrix like this and add it in front of my list, means that from my list, identify the element name matrix and print it. That's it. All right. So you have, if you have any list, if you just use dollar sign after it, all columns will appear, or all elements. Huh? More than one. Now you do slicing, like the first, the second. It will print. Oh, what am I doing? Uh, so the first can be printed like this. But now if I want the first and the second, why does it not print? What's wrong? Oh, wait. Yes. So now do you have only the first and the second, right? Hmm? Now, if you want the first and the third, I think you may do, you use C, you combine them, right? Hmm? Yeah, one and the third. Okay? You provide a vector of indexes to it. Okay? Yes. You are lost, Papa. No, if you are lost, call us. Hmm? No, you are jumping into data in few minutes. Yeah. Can we stretch for 5 minutes and then or 10 minutes and then come back? So we use dollar sign or a list of
United States, were both ends of the continents. When it comes to daily, when
Correct if you spell your name and put the full names there. Yes, choose any image. That is more like a resemblance of normally you put in the picture. This time you don't put in our picture. So you click on the emoji that is going to be appearing on your profile. Yes, in your organization, or if none, just none. If you're a student, senior student, something.
Is it wherever or whenever? Yes. It's wherever you are or whenever you want.
Just get to the courses. That is easier. Click on all courses. This one. I'm talking about this one here. All courses here. For you to browse all courses, then I'll show you which one to enroll on. It's taking me. It did take you back. That's yes, you have. In it's yeah, it's bringing you back. You need to refresh. So so you're there. But the process, oh, you need to refresh. So that see it open. Are we on the same? Yes. Yes. So I expecting everyone to click on this course, Arab programming for data analysis. Everyone, please. Everyone, please click on this course. It is the last one, Arab programming for data analysis. It is the last one. So when you click on it, your screen is supposed to be looking like that. If it is not, then you know. Just raise your hand. You good? Everyone is good? Are we on the same page? Like it is there. So which which means now you are enrolled on this course. People online, are we on the same page? Let me who is online? Need to mute your speaker. Muting. Yeah. Hello? People online, anyone with a question? So we are all on the same page, right? So I'm going to show you one more step, which is how you're going to submit the assignment, right? Now that we are all on the same page. So when you scroll down at the bottom, you're going to see something like this. It says submit your project, right? So this is where you're going to put in a link to your project. A link, not a document, right? Because you can't give your codes in one document or Excel. So we are expecting a link because at the end of the at the end of the session, you're going to be all having GitHub accounts, right? Dr. Lemma.
Yes.
The expectation is that everyone is going to be having GitHub account where their codes and everything is going to be.
GitHub.
Now that you're entering the era of the what do you call it?
It's the era of data.
Yeah, the era of data, but I'm trying to figure out the right one. It's the arena. You're entering the arena of data scientists. So some of the technologies you have never had are actually there. So data scientists use something called GitHub.
It's another environment.
It's an environment, technically, an environment
Just for collaboration.
where, yes, people collaborate, where you create your projects, publish them from there. More like I'm hesitant to call it a social media.
Like social media.
If it's kind of, but for coding,
Yeah.
not for social
Say
interaction.
It's specific social media. For some
Okay, you can call
area,
it that.
some domain.
Yes, yes,
Because
yes.
It's coding.
scientific.
Yeah, it's a coding media.
Yes.
So when you develop your project, you're going to publish it from there, but then you're going to bring your link here. So whenever someone wants to check your work, because the trainer is going to check your work, he's going to be able to find it there. So as much as you're going to be working on your codes on your laptop, they need to be published somewhere. So that's where you publish them.
It's very easy. We are not going to use any code. No, there is that. No, we are going to use the interface. The GitHub desktop.
So every time, this is where you're going to upload your capstone project, right? Yeah. So
Maybe just one line of code.
So here are the videos, more videos that you can explore. Very soon you're also going to find there the notes, the reading materials. But yeah, the videos you can always check. So when the certificates are out, please look here. When the certificates are out, you're going to find them here. Do you see it? So when you click here and you have worked on your and you have worked on your capstone project and it has been graded, you're going to find your certificate here. We just download it. Are we on the same page?
So how do you log in again? Is it automatic now when you are registered?
Okay.
You log in using
Just okay, branch out. Let him get out and then you show him how to come back.
No. I just
Because you have now created an account. Next time you don't sign up again, you log in. Yes.
automatically. I mean, it captures it.
Yes, it's going to know that it's you. But just don't change the email. Because if you change the email, it's going to recognize you as a different person. A new person who is trying to be on the platform. Are we good? Okay.
Check the ones who have written down. Check if your name is there. Check the picture of the people written.
Okay, we are good. I don't want to keep us stuck with this because we need to start the analysis phase. Right? Okay, good. Thank you. Thank you so much. Thank you.
So let's get back to our list. Right? Can we continue? Yeah, so once you have a list defined like this, right, with elements, so to access those elements, we use the dollar sign, right? So if you use dollar matrix is going to print the matrix, right, that you stored, the matrix A, right? If you do dollar vector, you are going to see the vector. If you do dollar data, the data will come. The data set. Okay? This is to tell you also that anytime you load data in R, this is how it will be looking. Yeah. And if you want also, yeah, so anything that is contained in the list will be displayed. Now, the question from our colleague is, what if I want the first and the third element of the list? Now you provide what So if I want to add a new sorry, a new element to my list, so I provide the key or the name of the element I want to provide, and I can simply add R programming for data analytics or something like that. So this will be added to the list of elements in my in my list. Then at the end, you can also print it. Let's print my list. Hmm? What do you mean by shuffle them? Hmm?
If you want to add the course name after before data,
Yeah, it's doable, but for what? Yeah, it's doable. You can do that, but I think it's just maybe you can define a new list, right? Let me try something. So if you do this, if I do vector, the vector comes, right? So if I put now course name here, so course name comes first. So then you can assign it to another vector, another list. Yeah. Yes, yes. But it's just purely manual work, which is not advisable. So here we can also add, yeah. So that also work. You can provide a list of indexes or and also a list of keys you want to visualize. Yeah. Can we continue? Russia. Color where? Listen.
You was asking after
I know about it.
I was trying to, so that means you will be open.
That's good. So how do you drop elements from a list? So remember, everything we are doing here, they apply also to data frames. So a data frame is a list, but a list is not a data frame. Yeah. So how do you drop? Imagine if you want to drop maybe drop the element data from the list. So you can just access it. So you write my list like this. So how do you access data from my list? Sorry? Yeah, you can $sign, and then you select what you want to drop. So I want to drop data. So what you have to do is just assign to it the value null. Okay. So if you turn this one into null, it disappears from my list. Okay.
The data is
That means my electronic data is going to.
Yeah, it should be destroyed, and either the name. Yeah. Now, if you want to check the names of elements in my list, now data has disappeared. Yeah. Mm. Okay. So this how we drop. It works for everything we apply to the list now is also yeah, we can apply it also to data frames. So that said, let's now move into learning about data frames. Hmm? Vous êtes à quel niveau? Okay, okay. Mhm. C'est bon? Ça marche? Ouais. Mm. So,
I have a question.
yes, please.
What is the implication of the new
Mhm. So the null it means empty.
empty.
Yeah, it's empty. So if you empty everything in a column or of a data frame, or you assign the value null to a certain element of a list, it destroys it completely.
Delete.
Yeah, like deleting it. Yeah, yeah, but there's also a different way in when you be talking about data frames. You have many ways to delete. It's not only this one. Yeah, you have many ways.
Maybe if you want to delete some variable,
Yes.
non-important variable.
Yeah, you can do that. Yeah, yeah. Yeah. So data frames, as I told you, in R we have what we call inbuilt data sets. Okay. So one example we have like the East data set. We have the cars data set. So if you want to see the list of all data sets in R, you just use the function data. Okay. So this will print all the inbuilt data sets in R. So you have these ones. Okay. So they are already in the system. Okay. Okay. So if I take any of them, like maybe CO2. If I take the data CO2, I can just come here and then say data, and then put the data name here. So R is going to activate it in what is contained now in the data CO2. Okay. So once you have a data set, all right, when you display everything like this, sometimes it is, in a report, it eats a lot of place. All right. So there is a nice function named head function that just helps you to display only few columns, few rows of the data. So in R, it is just the first 6 rows. And you also have a function named tail if you want to see also the last 6 rows. So by default, the number of rows to be displayed is 6. But you can decide to maybe just display 3, or you can display 4. It's up to you. All right. Yeah. So this is for the head and this is for the tail. Okay. Yeah. So this one displays the first 6 rows of the data set. Oh, first 3. Thank you very much. So this one first 4. So last 4 rows of data. Are we together? So once you have data loaded in your system, there's something called data exploration. So you want to know the type of data you have, as columns, data structure. We call it data structure. You want to get summary of your data so that you can already identify some issues with your data. Okay. So the first thing we can add is the data structure. So using the str function. So the str function applied on any data gives the data structure of the data. Okay. CO2. So str of CO2 gives the data structure. So the struct provide the structure of CO2. Okay. So it tells us about the number of rows, number of columns we have, and so and so. Yeah, carbon dioxide. Hmm. Hmm. Good.
Why
Hmm?
why
It's just among those.
is it an example?
Yeah, just took one. I could have took like maybe DNAs. I can put or seed belts.
What's the important of this list?
Those are like when you build a package. Sometimes you would want also your method to be applied on data. So some people who publish their packages in R, they also provide data, so that when you load their package, you have ready to use data practice. And those ones they come directly with R. Yeah, so you can use them. They are already well cleaned. They are not dirty. But the ones that we are going to import today, you will see hell. You are going to see, yeah, the struggle in data wrangling, data transformation. But those ones are already ready to run examples. Yeah. So I just chose randomly one. I could have chosen Titanic. Yeah. UK gas, everything. Yeah. And USA arrests. So violent crime rates by state. So you can run your examples one. Yeah. So if I want to get the data structure of this CO2 data, yeah, this is what you get. So it is saying that the data set has 84 observations and 5 variables. Okay? And we have a specific functions to get even the number of observations and the number of variables. Okay? So and the variable named plant. Remember, $plant. It's just like in this. Okay? The variable named plant is what? An ordered factor. So an ordered factor is a variable with categories, but those categories are ordered. Let's say education level is an ordered factor, right? Primary, then what? Uh, Bachelor degree and then masters and so on. So it's an ordered factor. So you can have 1, 2, 3s, yeah, or QN1, QN2, QN3. It's up to you. And then type here is a factor with 2 levels. All right. And this display can also, you can see 3 levels, but you can see sometimes if your data has a problem, you see Quebec here, but another Quebec with a small q. So you can identify problems from here directly. Yeah. And treatment is a factor with 2 levels, and the last 2 are numeric variables. Okay. So now, after structure, you can also, if you want, you can also check your data summary. So let me continue with the hyphens. So data summary. So what do we do with data summary? So data summary, if I display it, you are going to see. So you see. So for plant, which is another factor, you see that the first category QN1 has 7 what? Those are observations. We have 7 observations corresponding to QN1, 7 observations corresponding to QN2, and so and so. Okay. And for the type, you have just 2 types, Quebec and Mississippi. So let's say they are cities, and then among those 84 observations, for half of them go to Quebec and half of them go to Mississippi. And the treatment the same, right? And now for continuous variables, you have like those indicators. You have the minimum of the variable, and then you have what? The first quartile and the median, which is the second quartile, and the third quartile, the mean, which is the average, third quartile, and the maximum. Yeah, yeah. Just it gives you like a glimpse of the data, or a summary of the table. So now you may also identify, if you have any missing value, you also see the count of missing values directly, in all of them. Okay. Yeah. So I want us now to start dealing with real data, because we still have many things to apply on data. So let's do it on the datasets that were shared with you. Okay. So data from external sources. So it could be file, servers, etc. Okay. So now we are going to start with files. Okay. So today we are going to import data from CSV files. So CSV stands for comma separated values. Yeah. CSV is comma separated values format. CSV. It's actually it's just actually you can build it from Excel if you want, or from a TXT file. Yes.
I think that familiar things for many people in our application.
Yes.
Excel.
Excel.
SCP.
CSV is very familiar. Yeah, very. It's everywhere. You can open it in Excel directly. Yes. It's very. So I shared data yesterday with you, and mine is here. I'm going to copy it, and I will move to desktop where my folder is, and I will just drop it here. Yes, you do. So you copy it and paste it. Huh? You decompress it, copy the folder and paste it. Yes. Yeah. All folders. Yeah. Yes, but you decompress and then you get now the yeah. You unzip. Yes. Unzip looks like you want to unzip your decompress. Yes, decompress. So if you put it in the project folder, you are going to see this if you click on file. So it's going to appear if I refresh. Where did I copy it? Where is it? Let me paste it here to see. It's not working. I think I pasted mine in.
Copy paste.
Yep. Yes.
We have to paste where?
Oh,
Paste it to where?
I pasted mine in the wrong one, wrong file, wrong document. You know the folder you created yesterday? Yes. Yeah.
This is.
Yeah. So copy all of them. No need. Just the data files. Because even Excel is telling you that I cannot meet. Copy. Then you go to the folder. No. Yeah, file explorer. This file explorer. This one. This. So where is the?
It is.
No. Where is the?
I put it. This is. I extract it in this.
No, the project folder of yesterday.
This is the project.
How?
If I click here.
No. Open your you can. Let me check your app first.
It is my
Oh, okay. So you just paste it there.
Huh?
Just paste it.
Yeah.
No, where we were. Here. Click here. No, not that one. Yes, paste it somewhere.
Yeah.
No, but you have to create an. Those are the Excel files.
Yeah.
Can you open it?
I put it in.
Oh, okay. So let's go back, and then you rename this as data. That's it. Yeah.
That's it.
Yes. Yes. That's it.
And then
Hmm? So if you paste it, you paste the folder in your environment. Rename the folder as data, so that we can run the same codes. Hmm?
yeah.
Yeah, good. That's good. Do you have it? Hmm. So it's the folder data coming somewhere. Hmm.
I don't know why I need this space.
It's all good.
Huh?
Yeah, it's fine. Yeah, it's even advisable to have spaces. Yeah. Mhm. So let's check what is in the
Sir,
folder
sir,
named data. Sorry,
I
not
was a
yet there.
little. Yes, I don't. I didn't get well about how to paste that thing, that folder.
Okay. Can you share your screen so that I can show you how to do that?
Okay, let me see.
Mm.
Share the screen. Entire screen. Can you can you see?
Yeah. And-
Yes. Here is the raw data.
Mhm.
Now, how to paste it on the environmental Windows?
Your question is,
How to paste that raw data? Because you said that we have to paste that folder here, right? On raw data environment.
Mhm. Can you click on it so that I can see?
Mm-hmm.
But there's something I don't understand.
Yes.
Why do you have like so many files in your working environment?
I don't know. I don't know.
So it means that you didn't create actually the project.
The project.
Yeah. You didn't
Oh,
create any project, like project folder. So what you are going to do is, can you right click and can you go to file right now? The menu
uh-huh.
file. Go to
Menu.
file. Up
Like
there, file. No.
file, file.
So
Mm-hmm.
yeah, and then you save as.
Save
Check the
as. Yes.
options. Yeah.
Mm-hmm.
Then go to your desktop.
Desktop. Okay.
hmm And then create a new folder.
Create a
See
new
new folder
folder.
up there. Yes.
Yes.
Yeah.
Mm-hmm.
Call it maybe R programming.
Uh-huh.
Yes.
Now open it.
Click on. Yes.
Okay.
Open, and then
And
save
save.
it there.
Okay. It's saved.
Go to the other file, the data plus R programming.r.
Here.
No. Please. You know you have two scripts open. I want you
Mm-hmm.
to save all your scripts somewhere. You know, you have saved the R basics data plus, right? Is
Mm-hmm.
the one you started with. Please go to your scripts. Where are the scripts?
Script. You mean that part, right?
No,
Script.
the .r file. No, please don't go to file. You know, you'd see data plus dash programming.r. The very
You mean
first file we opened. The
uh-huh.
yeah, do the same. Go to
Save
file
again.
now and then save as. Yeah.
Okay.
Mm-hmm.
Desktop.
Desktop. Yes.
R
R
programming
programming.
and save.
Okay. Now you go to the top right corner, and then you see project is
Top
none.
right.
You have not created any project. So new project.
Mm-hmm.
So you
Save.
say save, yes, and then from an existing directory,
Yes.
and browse now or where your new folder is.
Okay.
Then open
Okay.
it.
And create.
Then create. Yes. All right.
Yes.
Yeah.
Okay.
Now you can see your files.
Mm-hmm.
Yeah. Now the only thing you don't have in this folder is the data.
Okay, so I have to import the data in the desktop and the folder I've created now.
Yeah.
Okay.
So you can just go to your file explorer, copy and paste in the
Okay.
file explorer. So where is the raw data?
Okay.
Mm-hmm. Just copy it.
Mm-hmm.
Yeah. Go
Desktop.
to desktop and paste it. And rename the folder as data with capital D.
Names. Okay.
That's it.
Yes.
You're all set now. Yeah.
Thank.
Now you can open your app basics from file. Yeah.
Okay.
Yeah.
Thanks.
Now, yes. So now if I want to check what is exactly in the data folder, so there is this function we use, which is dir. So dir or dir, yeah, directory. And then you just need, if you just do directory like this, it will show you all folders and files that are in your current working directory. Exactly this. Yeah. But now if you put the specific name of the folder data in the dir, now it is going to show you what is exactly in data. So open quotations and then use tabulation. You are going to see now folders that exist. Okay. So now you are instructing R to show every element that is in the subfolder named data. Okay. And now you are going to see your files. So you see climate, raw data. So CSV, patients, CSV, trade, CSV, climate, CSV, and students. Yeah. Hmm? Hmm. Hmm? Hmm. What does it say? Have you run the code? Click on play. But when you run, you check down, check under the chunk to see whether there is the. Now I see. You know, your chunk is not closed. Yeah. There is a huge problem here. Yeah, it's showing. See the result? Yeah, yeah, yeah. Hmm. So there's something, you know, in R is flexible but very, very stubborn. If you don't have your delimiter closed, you can see the play button, but nothing is going to run. Yeah. So until you add the three backticks, yeah. Otherwise, you are in trouble. Okay. Yes. So now we have 5 files in our data set. I'm going to import the first one, which is climate, and the rest you will do it. Okay. So importing data in R. So CSV. CSV is comma separated values. So I'm going to say climate row is equal to, so we have the read dot functions in R. So we are reading from a file. So use read.csv, read.csv. Hmm? Yes. Read. Now you have to give it the full link. Huh? No, nothing is in capital. No. Everything is in the lowercase. Yes. Hmm? You know, in R Studio, when you start writing a function, R Studio will give you hints. So you can select from them, like read.c. Then you see the function. You just hit enter. The function will be activated for you. Hmm? So you don't have to write in full. Read.c and then bam, enter, and then you have it. Hmm?
There's another one.
You can try it also. Try the CSV2. Yeah, you can try CSV2. They have their particularities. Yeah. So let's use the CSV and then you can use the CSV2 later on. Yeah. Yes. Now to give the full path to this, you know that you can use the tabulation, right? Tab to get the subfolder data. And now when you use tabulation again, now you can see all the files that are in what? In the folder data. So I can click, yeah, I wanted climate data, right? Climate row. So it's this one. And that's it. Can run. So now if you check up here, you are going to see climate. The data is, if you click, yes. Yes. So you open the quotations and you have the touch. Tabulation is above, on top of caps lock. Yeah, so you use that tab. You are going to see the list of all elements, those ones. So you can enter. If you see data, you can enter, and then you use the tab again to select the file, the specific file you want to use. Yes. Then Control Enter to run the line. Control Enter to run the entire line. So wherever you are, like, let me check. So I want to make sure that you are correct. All right, that's good. See the assignment? Assignment is not like this.
It is it all or something is count?
It's this one, shift and this.
Shift.
Yeah. That one. Now you can run. So if the assignment is complicated for you, just use the simple equal. Yeah. If this one is a problem for you, use this one. Yeah. So you can just click on the data name there, and then it will open it as if it was in Excel. Here. You see, when you import data, you are going to see it, the data name here in the environment. It's here, climate. Yeah, just click on the name. Yes.
How do you move this?
hover somewhere here, somewhere over here, then you can drag. Yes, yes. But if you make it disappear, it'll be bad because this is the console. You need it. Yes. Hmm. It's not Excel. This. Sorry. So it is not Excel. It is maybe R made simple so that people who use Excel can see data in a tabular way. Yeah. So you cannot apply any Excel formula here or add a column. It's just the display of the data. Okay. Yes, please.
I'd say sorry.
Mm.
It's like what are these?
Okay. So this is a new functionality R Studio has. So it is just giving you the summary of your columns. It was not there before, but recent updates they provide, like, yeah. But for me, it is very, very useless. Hmm? It doesn't make any sense. Hmm? Yeah. So it is trying to give you like a glimpse of your data. That's it. Hmm? Okay. Now you see that this data set is already in the memory, right?
So if you want to go back, you have to.
You click on the name of your script. You click on the name of the script here. You see, this is where the data is, and this is where the script is. Just move. This is what we started with. Yeah. You just navigate.
It is becoming really.
Interesting now. This is what you wanted.
But before the other things that you are zero.
But you come back to those crazy things and apply them on the real data. But in a very fancy way, not in that hard way. So now I can decide to display few lines of my data directly in my notebook. So I can use the head function, right? Yeah. So if I print, I'm going to print the entire. Yeah. So if it is in a report, then it is bad. It is going to eat a lot of pages if you have a long data set. But just print like head gives you like the 6 first rows of your data. You can even reduce to 5 or 4 if you want. Yeah.
Can you put more than
Yes.
by using them?
Yeah. The second argument is actually the n from the first one. Yes. Mm. So you can even say display the first 100 rows. It's up to you. Yeah. Mm. Hmm? Vertical. What do you mean by vertical? Hmm? Hmm? Mm-hmm. So now this function, this is instruction, imported data into this variable. You know what is a variable? So now this variable contains the data that is in this file. So now that file can be seen, data can be seen in R, and we can manipulate it and do even visualizations. So that head function is just displaying the first 4 rows of the data. Yeah. So this is like a Meteo. Meteo Rwanda is having stations, right? So in the columns, this is the date where we recorded maybe the temperature, and then the rainfall is 100 and so and so and so in this station only. And then on another date in February, this January, February, I think this is something that is done monthly, right? So in February, maybe it is the average temperature in the same station. Before it was in January it was 20, now it is 26.3, and the rainfall is 17 point so and so.
Cannot randomly select the four.
No, if you want random selection, is another theory. Yeah, yeah, yeah. Yeah, if you want to select random,
It brings
the first number one up to number four. But if you want random selection, I can also provide the code for you.
And if you want, for example, to write 15, for example, you write a 15 and then
Yeah, 15. Yeah.
select 15.
Yes. So now if you want random selection, we use the sample function of yesterday. Yes. So you'll be like sample. How do you access the number of rows of this? Who can guess the number of rows of the? No. N row. Number of rows of our data, which is climate. And then we need, how many output do you want? Yeah, size is equal to 15. So this is giving you indexes. So this is giving you a vector of indexes. But now if I take my data name and then I use brackets on them, now I have, oh, what's going on? What did I do wrong? Undefined. We have like a 1205. And this sample normally should give me a vector. Hey, it's a two-dimensional data. It's a 2D, so I need this for rows, so I have to give the place of columns. Just a comma. Yes, thank you very much. Yes, yes. Yeah. Now it is randomly choosing, and now you have to fix the randomness. Whenever I run it, it's a different story. So you have to fix the randomness. Is it answering your question? Yeah. So if you just need 4 rows or 5, it's up to you. Okay. Yeah. So this just to see.
I think you are looking for a station ID that you are searching for a station ID.
You know,
Search key.
you know how to do it. You know. You know. Hey. And it's a very good question actually. You get the name of the data, right? Now, this is happening for rows. You want to filter rows for, let's say, station CL009. So you will just say, okay, how do treat climate row as a list. How do I access a station? So now if I have the data name like this, how do I access stations? $sign. Yes, dollar, and then I get station ID. And then how do I filter? Which operator? How did I count the number of females yesterday? No. Huh? guys, it's so simple. So I want to filter data for CL009 only. So I'm filtering for CL009. And when you run it, so you have the sub data for CL009. Everything is CL009. Okay? Hmm? Yes, but now the problem is, can you trust this date? It is telling you that it is even character. So this is the work we are going to do. We have dirty things here. So yes, we are going to clean the column of dates, so that now if you want to see the temperature monthly, like a trend, you cannot do it now. Yeah. Yes. Oh, okay. Okay. Any other question? Now, my question to you: if you want more than one CL0019 and CL0011, how are you going to do it? Vector of, huh? Yes, you can put and, which is very good. Hmm? You can put and. This is actually the right, yes, and then you just copy this part, and you can do for 11, right? Very, very good. But now, let me check whether we have 11 there. Where is the display? I don't see it. Ah, it has not picked anything. Okay. So let me just do this. Hey, it's not and, it's or.
It's all.
Yes. You know, and is when you have two different. Yes. Yeah. So now you have C11 and then 9 up, and this is the 11 one. Okay. Yes. So do you see now the reason why we were using the and or, and now it is coming clear? You know, you are applying the and operators, the or operators. Yeah. So we are going back to the knowledge of yesterday. So the more the stations you want, you can, but you can also do simple, and it will bring you the same result. Instead of using and, I told you yesterday about an operator that is in. Okay, is in. Now you can use vector. Yes. And you know, it is even reducing the number of lines. This is shorter, but does the same thing as the code before. Yeah. And this is even so long. Like when we'll be using real package for data science or for data analytics, you just think something and then you add a pipe. You know, we pipe data. It's just like a pipeline, data pipeline. You just send data into this function, treat it, and then add another function. It's just like one line of code. You do the cleaning in everything. Yeah, and it will become very, very interesting or a nightmare if you are not focused. Yes. So this is the semicolon is two-dimensional data. For vectors, you don't need a semicolon. So this is a dimension for rows, and this for columns. So if you want to filter data for columns, you are going to write instructions on the other side here. Yes. So the NAs, this means missing value, not available. So in the afternoon, we are going to know how to deal with missing values and or maybe outliers also. Hmm? Yeah. Yes, lunch time. Let's go recharge and then we come back to clean the dates. Hmm? Yeah, we start with dates. Hmm? All right.
Unguka Bank, sorry, Unguka Finance, not currently bank, as data and performance analyst. And I did statistics in a bachelor, and I'm doing masters of financial engineering. I think that's enough. So we are going. Okay. How about people online?
The same screen as you presented.
Yes, it is the same. Ah, sorry.
I think you're presenting two different screens.
Is this the same?
Yeah.
Uh, is it visible?
No.
Okay. That's all. So we are going to proceed with the data cleaning that we are for the data set we provided. I think we started by using climate, if I'm not mistaken. So it was the climate data that we was using. So before we proceed to the data cleaning by doing practice, so we normally, okay, not the same. Don't look at this one because we are going to start from, but for you, continue where you are. It's fine. So we have, let me import the data set first, and then we talk later. For me, I'm going to call it data. Yeah, I think this is the data set we are going to use. The climate data, they send it to group WhatsApp. So before we start doing the data cleaning, I want to introduce something called package. I don't know if you have heard about it. Yes? Okay. So mostly for us to simplify the work, when we are dealing with the other programming, especially for data analysis, data cleaning, those kind of things, we have what we call package. So if we say package, it's like both of us we enter to the gate, and yet they was asking us like the permission to enter to the gate to the campus, something like that. In other programming, when you need to do something regarding maybe to the other to regarding to the analysis, whatever, we have what we call the code, like the packages the developers they develop, so that when you need to do something regarding maybe to the data cleaning, there is a specific package they design for that kind of sequence activities. And if we need to use it, I, if I'm not mistaken, from where you started by seeing how you can develop the codes from the scratch, like those functions, which is basic, like a week, if you need to program something in your mind. There is where we started by using which functions, if, loops, whatever, those kind of things. And those who develop the other programming, they see it and then they said, for example, if you need to import the data, there is no need to do those manual wrong codes. Let's design the package that is responsible for doing those kind of things. What you need to know for you, it's like to know that if I'm going to deal with every element we normally knows in data management, like data cleaning as well. There is a package, for example, called tidyverse that is going to give us a hint to simplify those kind of work. That's what package means. I don't know if you understand what package means. Yes. So from there, hmm, it's an application, something like that. Like as I was giving you an example, you enter on gate, but before you enter there, they need to ask you the permission so that they can see if you are authorized. That logic, when we need to do like data cleaning, there is a package you need to load into like into other programming environment or setup so that like you can proceed for doing that. Yeah. Is there any way to write? That's fine. So, and then from there, we will see that we have a lot of packages, what is going to help us maybe to import the data set in Arab programming. As I said, one is tidyverse for data cleaning. So we are going to go through about, we normally have almost 80 elements, which is a key, but not limited to be increased. It will depend on the scenarios that you are analyzing. In data management, we have 8 elements specifically for Arab programming, like which is common doesn't mean that it is only that. Like summarize as you had about it. We have what we call mutate, transmitted. So maybe I'm going to write it so that I cannot forget it. So we have what we call summarize, and I think you have heard about it. Summarize, it's where you need to summarize your data to understand the structure of your data set. Because everything you do comes by like, you need first to understand the structure of the data set you have. For example, we have the data set here of climate, but yet you don't know what you can do unless you explore the data set, for example, to know how many numerical data I have, categorical data, number of observations, data type as well. So that when we are going to handle, maybe if you see that there is a missing value there, the way we handle missing value to categorical data, it is a different way we handle missing value to numerical data. So that's why, first of all, we started on summarizing or getting a structure of the data set in the sake of understanding that data as well. Are we on the same page? Okay. I don't want to preach. So we are going to run. I don't want to preach. Like, I need you to be like interactive. I said summarize. I'm going to write it here so that we can discuss it. Mhm. Uh, for you, are you using Markdown? Okay. Okay. Yeah, the codes are the same, but let me shift to the other Markdown so that we can go on. Sorry. This is Ara Studio. Still, it is the same. The way you write the code, it is also the same as what you write in Ara Markdown. But let's use Ara Markdown. Okay. So this is the same as well. It is the same. The code are the same because I was shifting to the Ara Studio as normal. But Ara Markdown, it's good because on Ara Markdown, you can do analysis at the same time doing interpretation of analysis. Because you have seen the way you can also add the comment, and you have seen also you can compare it in what this is Ara Studio.
And then we are using like what was in studio, but there is what we call other schools, and then other mark. For you, are using this one.
This is Ara Markdown.
But no, before.
Ara script.
Other script. Why you use this? The very first one you open yesterday is other script.
Yes.
And now it is Amazon.
What I used before was Ara script, but the codes are the same. On different, those are the things we in Ara Markdown we have what we call chunk. That's where we put a specific code for analysis. And this empty space we have here in white color, from there you can write any comment you want, which means you can start by putting the interpretation. Maybe we are going to do the analysis for this data, like to put the introduction for us to have be a brief understanding on what we are going to do. In other Markdown, where we have empty space here, you can come and write anything you want. Instead, sorry. Let me use this one. Mhm. Yeah, so we have it here. Let me proceed to this one. I think I have it here. Okay. What Dr. Remo has used before. So as I said, like in our program, in our Markdown, that's where you can come and put like the explanations of what you are going to do in this white space we have here. Like this one, we have seen that operations, whatever. So you can have like the way to put those comment or interpretations of what you are going to do, but also at the same time, once you run and then you get output, we have seen that the output, it goes directly to other Markdown. But on other script, the output is going to come on this side that I'm talking. That's where the output is going to come. And in other Markdown, you have seen that the output is going to be inside, like below the code drive. For example, let me take an example here. So maybe Let me add this one, then I try to run. You see. You see what I'm saying? In R Markdown, that's where the output is going to come. And from there, from this one, I can come here and then I put the interpretation of this kind of things. That is the easiest way when we are using R Markdown and also R script. I don't know if you had the difference. And from R Markdown, you can convert it directly in Word document, in a PDF document, in a PowerPoint presentation, whatever you want in R Markdown. That's why many people, they used to use R Markdown in coding. And where we put the code, you see this what we call chunk. This is the chunk where we used to put the codes. Like the way you write the code here, if it is the code of importing the data in other programming, it is also the same as the way you will use it when you are using other script. There is no difference. Only the difference are those functionalities that you can do. And before we move, as I said, we are going to do the data cleaning or data manipulation in Arab programming by using this climate data. But before we start to practice, normally when we say data cleaning, it means that we are trying to clean the data. Maybe if you are cleaning, you add, you remove, whatever, you manipulate. You have something, but you need to standardize it to the extent you want. From that process, that's where you will have to remove, to add, to adjust, something like that. And in other programming, as I said, there is some 8 elements, which is a common, not to say it is almost the 8, but it is like the principles we used to know. If they ask you, what do you know in other programming about data management? One, as I told, it's summarized. First, you have to import the data. Once you import the data, there is also the libraries we are going to see, or the packages we are going to see that is helping us to import the different data sets. We have had on Excel CSV, but also you can have another extension of Excel as workbook we normally use in Microsoft. You can have, Stata. Is there anyone who knows Stata? SPSS. You can have the dataset in SPSS extension, and yet you need to import it in other programming. For us to simplify, there is a specific package that helping us to import that data that has a lot of extensions, because other it can import more than maybe 100 data files. It will depend. And you can also import the data from online sources like Cargo. From there, you can import the data from there into other programming, and then you do analysis without doing any further manipulations. So the first is to import the data. The second one, it's summarize. The second one is summarize. We summarize for us to understand the structure of the data we have. And then third one, we have what we call uh, we have summarize, as we say, summarize, summary. We have also rename, input to rename. We have also what we call order. I'm trying to talk it. Maybe we will do some practices regarding on that. We have also orders. Okay. In this one, are you see it? Still now.
Increase. Do you have a problem increasing?
I'm asking you.
It's not.
Okay, I'm zooming, not increase. Okay.
No zooming. I don't zooming.
Okay.
Not the same structure. You have to put yes. So it's similar structure.
Okay. Let me see if we can increase the size. Can I put on maybe this one on 12?
Yeah, at least, yeah.
This one, maybe I can do.
Yes.
Now you see it. Mhm.
Yeah, so now you put it back.
I was like, I did zooming without increasing the size. I was trying to increase the size of text to do something like that.
Control plus.
Yes, I think now you see it. Okay.
Yeah.
Mhm. I'm writing here as a draft. Don't take it as a code. It's a draft so that I can explain it. Uh-huh. So we said summary, we said the rename. It's rename, it's like to change the name to the way you want. For example, I have the data set because you started on summarizing, and yet you see that maybe the data set has big names. Let's assume that you get the data from the field and it has what is your name, what is your agenda. From there, you will need to minimize the longevity of the variables. That's where you do the rename in other programming or whatever, any kind of programming that you are using. That is the logic of doing rename. And then order, maybe you need to order from ascending or descending, whatever. And we have another what we call transmitted. Let's start on mutate. Mutate. Mutate, it's a way, it's like creating a new variables based on existing. Let's say, for example, we are going to have an example here. We have a temperature. We have the variable called temperature, rainfall, humidity, whatever. And then there is a new variables. Maybe we need to calculate rain score, for example. I'm taking an example. And we know that when we are calculating the rain score, we need to take temperature plus rainfall plus rain humidity, something like that. So it means that we are combining the variable which is existing in our data set to generate the new one. That's what we call mutate in other programming. And then we have also what we call transmittate. Transmittate, it's like we are creating new variables, again, based on existing, but delete what I used. I'm no longer need what I used to generate that variable. I need what I generated from that. You understand mutate? Okay. You, yes, okay. I'm going to do redo. Okay. Okay. So you understand mutate. Mutate, I'm going to repeat it. Mutate is like creating new variable in a data set based on existing and keep those variables you use. Mutate. But transmutate, I'm going to generate new variables based on existing, and what I use to generate that new variables, delete it. I'm no longer interested on it. Keep the new one, but existing I used, delete it. You see, like we are going to calculate the rainfall score, for example. In mutate, we take this one plus this one plus this one, and we gain new variables, which means our variables, if we have the 5 variables before, and we add the score rain, the variables is going to be 6 for mutate. But if we use transmutate, and yet we use temperature, rainfall, humidity, and we do transmutate to generate rain score, those 3 variables we use, they are going to be deleted, which means the variables are reducing. Yeah, that is the logic. Yeah, that's why I said you can choose whatever you use. When you are using mutate and transmutate, you have to choose whatever you can use. Maybe you can see that you no longer need that variable, and then yet you need to delete it. So we have seen also transmitted. And then we are going to do some practices based on those scenarios by using climate data. Doesn't mean that this is a process you will do when you are playing with the data once you are trying to clean it. But at least it is basic. Transmitted. Other one is we have imitate, we have rename, order, imitate, transmitted, distinct. You use distinct when you are checking duplicate. When we are checking a duplicate in a data set, we use the function called distinct. So we are going to see it. Because most of the time it's important to know if you don't have duplicated value in your data. You know the bad thing when you are using the data which has the duplicate. Mhm. Other one, is there anyone who have a question? Yes? Okay. Dismutate. Other one, it's arrange. Mhm. Arrange, it's like you have the data. I think you have had it. Like you have the data started by station ID, I don't know the name, sensory, date, temperature, rainfall. The first variables in order, like the first column, not variable. If I say variables, just understand the columns. Yes? First column. Because in real life, we used to say the variables. But when it comes to the programming, if we say variables, it's like the name we are going to assign, like the variables, it's what we are associate with, something like that. But if I'm talking about the variables, it is in real life. Because when you have a data set, you will not say that this is a column number one, this is a variable number one. But you normally knows in statistics, it's a variables when we go, let's say you are going to conduct a survey and you will need the questions to answer so that you can get the response. Those are what we call variables. And we have numerical variables, categorical variables. I think you know. Yeah. That's why I'm saying the variables, I'm not confusing you. I want you to note it. So this is the column number one, column number two, number three, number four, whatever. And then most of the time you will see that maybe the last column I have here as six column, I want it to have it as the first column. Yes, that is arrangement of the variables. Yeah. I think uh what else I forgot? Okay. I say the eight. We have some one, two grouping. Yeah. Okay. Grouping. Yes. I think this one. Group grouping. Ah,
It's not like let's mutate. No, grouping values like when you want to do summary table for maybe countries. So yeah. Group by country and then summarize the calculation as statistical quantity. Yeah, it's not together. So that counts. That's nice, though. Uh-huh. Well, for example, last moyen per page. One average page per country.
yeah. Sure.
The group by country and then
Yeah. Or let's say we have a sensors here, sensors A, B, C, something. Maybe you need summary statistic, average rainfall per centuries. And that's where we use group by. I think you understand it. Yeah. Are we on the same page? Yes. Okay. So now let's practice this one and then think we are going to have understanding on it, the way we are going to use it. So both of us, we have the data set already in our programming. We are going to start on exploring it. Uh, Let me change the directory. There's no way to confuse. Yes.
That library don't tell you that would they
Okay. Sorry. So I forget to talk about the libraries or the packages. As I said, for us to simplify the work, to use that imitate, transmitate, rename, those things that we are talking. So there is what we call package. Into that package, that's where you can apply those formulas of mutate, transmutate, whatever. So to be able to use, for us to be able to use a name, order, mutate in a simple way by using a simple code line, we need to read the library, to read the package called tidyverse. Normally the package tidyverse, it is what we call this one. So this one,
You can, you can call it at, you can add it at any chunk wherever you want.
yeah,
On the website.
not always to have it at the starting, but when you try to do the serious project, most of the time you have to import the necessary packages before you start doing analysis. Yeah, but the tidyverse, it's specifically helping us for the data manipulation and also data visualization as well. Into the tidyverse, there is almost more than 10 packages inside the tidyverse, like that we will see what we call ggplot2. It is also helping us in data visualization. So that's why mostly they used to say that ARA is good on data visualization. It's because of that package called ggplot2. Yes, am, am I confusing you or?
And I think many things which are not, I think that person now is do something.
Okay, okay, I was like explaining to him. So what I said, we have what we call the packages. I think you had have it. Then for us to do the data cleaning, we use the packages called tidyverse. Let me go slowly so that you can understand it. And that package, you need to install it first into ARA programming. So the way you install the package in ARA programming, you say install. There is a code called install.packages. Install.packages, this one, and then you put the quotation,
Open bracket.
you open bracket, you put the quotations, and then write the name of the packages you want to install. And then you write tidyverse.
Install it.
Yes, if you don't have it, because for me I have it. So so there is okay, there is a packages when you download other programming, by default you will have it. How can we check that we already have it? Okay, instead of use install.packages, write in, installed packages, put in path install.packages, installed.packages, type install.packages and then run, open bracket and close bracket, put in path and then you run to see already packages you have in your other programming. Because at the time you download it, there is a packages comes by default. Because that's why you have had, like in other programming, we have the sample data set, carbon dioxide, whatever. Those are the data set comes under the specific packages. So to check the installed packages, use install.packages. Install.packages, and then you will run, you will see what is about. You see, for me, those are the list of the packages I already have. Yes. Type install.packages, open and cross bracket, to see the installed packages you already have in other programming. Yes. You are okay. For me, those are the packages I already have in my other programming. So other way, maybe the other way to search the specific packages you are looking for, you see that you need to be aware that you need to be aware of the packages you can use. So the way, or in a simple way, you can see it without seeing all. Maybe you can also say, if you try to use this code called library, it's when you need to load it. Yes, you have it, but also you need to load it. You can use library, and then when you are using library, it's a way of reading it so that other can be aware that you are going to use it. Try to type tidyverse. Okay, this one, sorry. Tidyverse, something like that. If you try to type the first character, they are going to give you the list of what you have in Arab programming by using library code. This is the library code. It's the library that's helping us to load the packages that you are going to use. You have many packages, but you have to specify what you are going to use at that specific time. Or other way, if you can you follow a bit to show you the simple way you can use it? If you come here on packages, see here on the right side where we have packages. We are not following on this side. From there, when you click there, there is also the list of packages we have in Arab programming, which is installed already. So you can come here on search and then type tidyverse. Once you type tidyverse, for example, they are going to show you the packages if you have it, because I come here and then I type tidyverse. You are going to see on the list, and this is a short description of what that package can do for you. Yes, for us to see the way you can also knowing the specificities of the different packages. Can you check if you have tidyverse before we proceed? You don't have it.
When you write like library tidyverse, they are going to ask you to install. So
Okay.
that's how I installed it.
Okay. Yes.
Just even if you want it or not.
Yeah, that's
Okay. Let me install it. So we are going to use install packages, quotations, and then we tidyverse. TWI verse. This one. Then we do run. Have to run. Yes, I'm going to install it. For me, I already have it. That's why they're asking me to update it. But for you, try to do it because we are going to use it. If you don't have tidyverse, I don't think that transmutate, mutate, those kind of things is going to work for you. Try to install it. Okay. Are you done for installing it? Okay. Make sure that you have internet. So are you done? Okay. Let me know if you have already started, then we proceed. So once we are done with it, maybe let's proceed. Okay. Okay, from here, let's view the data set to see the way it is. If we need to see the way data set look like, we can use view, and then we type the name of assigned the variables we have found. So I've seen that if you use view code, and then you put the name of data set, if to, I'm viewing the data set. Okay. This is not working. This one. I don't think in type the name and then you run, because I don't think in our view is working. I use capital V. For me, I use capital or small. I did it, but I didn't see. So I don't know the reason. Okay, yeah, it is working now. So okay, I thought that in a ARA we normally use more cases something. That's why. Okay, yeah. So we are going to see what we can do by using those 8 elements we mentioned to see if we can do something from there. Yeah. Okay. So we have station ID, sensor ID, date, temperature, rainfall, humidity, extreme event, countries. Those are the variables we have. So sometime, because we are going to see a lot. So sometime you may have the data set has maybe more than 100 variables or 100 columns. Are you going to scroll each by each? So what can we do now to see it? To see the name of the variables we have in the data set. So what we do, you can come and say column names. Column So if even you can say names in small letter and then put the name of dataset, close and open bracket. If you run, you're going to see the name of the dataset you have. Names, the variables the name of the dataset, then you close the bracket. Name, we are going to see the name of a column our dataset has. That's why I say you can have the dataset has more than 100 columns, and maybe you need to see the names of the variables so that you cannot get an error when you are trying to write the name of a variables. If you run, you are going to see the list of the variables you have. Mhm. You have student station ID, you have sensor ID, whatever. Yes, we are trying to explore the data. We have had on summarizing to see like missing whatever to see the structure of the data set. And now we are going to see the names of the columns of the data set we have. From now, after knowing the names of the columns, you can also try to check the missing value. Before we go to the duplicate, we can check the missing value. When we are checking a missing value or not in dataset, you have seen that we use which we use is not is.na. Is.na means null value. Is now. This is the code we use.
It's not in the package.
No, it's a code. It's a code. Is not. Then you specify. You open bracket. You specify the name of the dataset.
That's the code.
Is not. It's checking the missing value into dataset. Yeah. When we are checking a missing value into a dataset, because you can't analyze the data that has a missing value that should be treated before.
Is it your name Tasir?
Yes.
But you should have really told us because it's as if for you, in the climate change what is there. For us, we are new.
Okay.
Maybe what to be, I'm saying to me, you have told us this is maybe the name of the whatever, it has these things. So we enter when you know that maybe it has column A, column B, column C, that for you, but for me,
Okay.
This one is going to show you.
No, you just saw
Games
kind of.
no, already there. We don't know. For example,
It's raw data they share to WhatsApp.
This is the data I'm using.
okay.
Maybe check if you have
No,
it.
maybe you didn't get my
Okay.
you didn't get my question. No, we did pass, but you didn't get my question.
Okay. Maybe you can try to.
So when you view the database, you are able to really see
Yes.
the name from the data. Now he's trying to detect traces of missing values in each column.
You can't see the missing by viewing while using your eyes. That's what we are trying to. I don't know. Actually, I don't know if in a data set we have, if there is a missing value. But let's assume it's a job you get. You are not going to assume that there is no missing value, but you have to do like those kind of exploring, like for you to be able, once you provide the final result, maybe there is a missing information that was there I'm assuming actually, I don't know specifically, but I said you have like to summarize, to explore the missing value, to check the duplicate, those, yeah, to rename, those are the things you go through before providing summary statistics as usual. And what I'm trying, because we have the variable name here, and then we have the data set called climate, and we don't know if we have a missing value there. So I'm trying to assume like those things we usually do when we are doing analysis, because you can't say that this is the final statistics yet there is a missing value. We will see the way also once we see the missing. Let's by lucky, if we see the missing in data, you're going to ask me how can we treat it. That's where that is the way I'm using. Yeah, because sometimes we receive the data which has which does not have a missing value, and you are not going to check it. Well, how are you going to know that there is no missing value in the data? You have to check, because here we have a simple a few data set, but you can have the data set has 100 millions observation. That's what I'm trying to do. So then I said, if you need to check the missing value in data set, you can check the missing value for entire data set, but which is not a divisible way. We are going to do it for the sake of practice. But a divisible way is to check a missing value based on a specific column, and both we are going to do it. If I say specific column, like we have the station ID, and we know that this station ID, for example, that is the record of each participant, for example. If we see that there is a missing information here on this station ID, we are going to see why we have a missing value on ID, yet we assume that we don't have to have it. So if we have the missing value maybe on date, we have to see how are we going to treat that question. If we have the missing value on extreme weather event, so sometimes they used to say that let's assume you ask 100 people. It's an assumption to help you to understand the bad thing if you don't check this missing. Let's assume we asked 100 participants in a study, and you realize that 50 people, they didn't respond to that question, which means you're going to receive 50 missing. So from there is some thought. They used to say that if you have higher than 25% of missing value in a specific column, you can't provide statistics on that variable. If we there is some thought, they used to say that recently. So there is some thought they used to say that when you are doing analysis and then you see that on a specific column, there is a missing value which is higher than 25%. Sometimes they used to say you can't provide the statistics of that variable.
How do you know 20? How do you know that it's above 25%?
How do you know that?
Yes.
You have number of observation. Yes? Let's say we have 100 people who participated in the survey, and you calculate the missing value for a specific column, maybe called rainfall.
What is above 30?
You get like 20. You get that 20 divided by 100 times 100, divided by total times 100. That's where you get the percentage of the missing value. Yes? So there is some thought they used to say, if you get 25 and above missing value in a specific column, and yet that people, they are supposed to answer that question as a mandatory, you can't provide statistics. Yes. Yeah.
This one is equal that is energy.
Yes.
And the global data will give you true and false for each value
Mhm.
of the value.
Yes.
If you want to know by column, you have to ask
Yes.
how should you ask.
Yeah, I'm going to do it.
Column is column is this.
Okay. So if we do like is.na, they are going to tell you, you see what you are going to see. Can you follow, please? If use is.na and then you put the name of the data set, they are going to give you false, true, something like that. If they give you false, means that there is no missing. In our data, where we have a false, we have information there. We have a response there. But if we have true, it means that there is an empty. But this way we can't know how many. That's why we need to add other function called sum.
Sorry,
Yeah.
can you comment this name?
Okay. You want me to connect? When you need to check missing value. So when you use is.na only and you specify the name of the dataset, you are going to see true and false, whatever, which is not a divisible. Where we have a true, it means that there is a missing. If we have a false, it means that we have a record there. But to count how many, we add sum. We add what we call sum. Sum, and we close, we open bracket, and also we come again to close the bracket. So if I run, you see how many we have in on the entire data set. 107 on the entire data set. This is for the entire data set that has 6 variables. But the advisable way to check a missing value, we can't check the missing value to the entire data set because we can't know the percentage of each variables. Yes?
25.
Yeah, whatever.
Can be explored.
Yeah, but from here, when you need to check the missing value for the specific variable, you need to indicate it. Okay. So to indicate it, you copy this code again, you paste it, sorry, paste it below. To indicate it, that's where we come on the name of the dataset. We add, what are we going to add? We are going to add $sign and we specify the specific column. So let's start on temperature, for example. I say temperature variable. So let's check on the temperature. Here we are checking missing value. We are checking missing value on specific column. So you need to put the $sign and then you specify the. You see, we have 57. I want you to tell me the numbers you get. So we have 57. How many observations we have in this data set? Which, is there anyone who can tell us how many observations our data set has? How many observations? We can use count or any row, something. Yes? Or even when you use summarize, you can know the number of observations. Yes? We have 1205. Okay. Okay. Here. Wow. That is interesting. Okay. From there also you can get it. Yes. 100 to 1,205. That is the number of observation. And among those people, let's assume it is a people who participated on the variable called temperature, 57 observations are missing. Yes?
If you say observation, is it like
Number of response.
rows?
Number, yes. Okay, maybe, okay. It's number of rows. You guys are mixing it in real. Like, let me clarify this kind of thing so that we can be on the same page. In other programming, or maybe other programming, Python, whatever, when we are talking about the columns, it means that it's a heading, something like that. The programming language, they are using the logic of matrix. That's why we have heard about the matrix here. And then you said, you guys, nothing we are doing. Because when we have the data set here, in programming, they treat it as matrix. That's why they used to say column and row. Column means it's a question is we ask to the theory in real life, what we call variables in real life. And observation, it's a row. Row number one, observation number one. If I ask you to participate in a survey, the answers you will give me when it comes to the programming, it is in the row number one. If I ask other person, row number two, another row number three. That's what we are going to have it as observations. Yes? The single value here, like the single row in real life, it's what we call value. If we combine it, it's what is going to give us the observations. Yes? Which means if we say we have 1,205 observations, we have 105 rows. And if we say we have 5 columns or 5, you see, we have 5 variables. Here we have 8 variables. It means that in a data set, we have 8 columns. That's what it means. But and yes, columns, it's like headings. Yes, yes, yeah. If you have a data in Excel, you have column A, B, C, D. But when it comes in real life, when we are explaining the result, you can't say that we analyze 8 columns, 8 variables. Yes? And you can't say we was having 1,200, 200 and something rows. It was observations. Yeah, that's why I'm mixing it. Yes? Okay. From there, what I was telling you, among 1,205 observations we have in entire data set, in a variable called temperature, because we was interested to see the missing value in temperature variable, we get 57 missing value. Those are the responses we didn't capture. That's what we call missing value. Okay, the way I get it, I use sum is .na, put the name of the data set, I add, yes, I add square, I add sign dollar to specify the specific columns. Yeah. Yes. And I think you know how to specify the specific column. Are we on the same page? Did you run? Then you didn't get the answer. Okay. Scroll. Did you run? Okay. Okay. You forget to add some because they are going to tell you. Okay, select this one. Yeah, this one. So the way, see the way you are going to use it. Select it, then do Control Enter.
There's something interesting. If you want to see the code, then check
This one? Are you going? Oh, you have some? Okay. Okay.
I'm not ready.
Oh, young copy.
I want to report my grade.
Ah, okay. Did you see how we get it? So The other way also you can use, maybe we are not going to see each and every column. Assume that you have a lot of columns. Yes, and yet you need to see the missing values on each columns in a simple way. So the way you can use, want you to see the simple way. So you can use column sum instead of using sum, you see. Okay, you can copy this. From here you have seen that we use sum. Instead of using sum, you can use core sum, core sum, sums, something like that. If you need to see the missing value for each and every columns in dataset in a simple way, or in a single line, for example. If I say dataset, you understand it? It's a matrix. Dataset, like if you have a file of Excel, we say dataset. Yeah. Okay. You see, from here I will see on each and every columns, we have a zero missing value on station ID, sensor ID, we have zero, date, we have zero, or temperature, we have 57, rainfall, we have 50, humidity, we have zero. Those are the numbers we are going to get from there. So you didn't see the code. You say column sum. Column sum, open bracket, is not value, is dot na, and then you put the name of the data set there. This one, you see.
Dataset you can correct the file name.
Yeah, the file name. Yeah. Yes. Yeah. Column sum, open bracket, is dot na, and then for me I have it as climate row. Are we on the same page? Not yet. Are we on the same page? Okay. So from there, we are trying to explore the data set. Nothing regarding to analysis we have had. This is how you understand the data when you are trying to do the analysis. Because you can't say that percentage of something. We are going to see how you can get those percentages, whatever. But from here, that's where you explore the data set until you do further analysis.
And it is done by help of storing packet content bus.
Yeah. Yeah, you can't do this if, yeah, but you can do it, like I think Dr. Remahal told you, like those are the codes, you can read it from your own. But for us to simplify it, there is no need once we have the packages there. Yes. Okay. Then what else we can do from here? We are going to see how we can treat this missing value for us to have proper data set before we do further analysis. So how is there anyone who knows how can we handle this? There is a way to replace it or to treat it, whatever. Is there anyone who knows the methodology of treating a missing value before we do practice? Handling the issues of missing value into data. Like if you get the missing value in data set, is there anyone who knows the methodologies of handling it? Theoretically. Yeah, that's what I want to hear. Yeah, because we. Mm, mhm.
Basic values. And then for numerical columns, we can use the mean.
Okay. So you said for numerical columns, we replace missing value by using a mean. Oh, mean? Yes. Yes. For numerical column, when we are handling a missing value or eliminating it, we take initiative of saying that where we have a missing value, let's replace it by mean, average value. Yes. And if it is categorical, who knows it? I want to. Okay, mode. Okay. Is there anyone who knows anything before I add? So before you think about mean, mode, whatever, we have also the median. Sometimes we use median from there. So before you think about those kind of things, there is something I say you have to see for before you think about it. You have to think about the percentage of missing value in your specific column that you need to treat, because sometimes you will see that with okay, you will see that the missing value you have in a data set, it's higher than the people who respond to that question. And then you said, I'm going to replace it by mean, whatever, which is not true sometimes. Because if you are targeting 1,000 people and more to that value, are you going to brief the responses submitted by less than who didn't submit? That's why you need to look for the percentages. And we say the missing, when do we say the missing value in the data? Not all the input values in the data set are missing. You know it. Yeah, it is a missing value when the question was mandatory to each and every person. I'm using examples of a person for us to understand it. That question was mandatory, and there is some people who didn't prefer to answer it, but the question was to the same people. But sometimes that's where we can say that there is a missing, because people they skip it because they don't want to answer it, but it was mandatory. And sometimes you may see the survey for the specific questions directly to the male, other which is directed to the female, or maybe the female are not responsible to that questions. If you see it in a data set, you can't say that is a missing. Yes?
Nice.
Mm-hmm.
Now, you are saying the data set.
Mm-hmm.
How many can that maybe they are over, not over 500 is not respond. For example, in this data set called
Crime. Okay.
how many can you know that there's supposed to be 1,000 questions?
This is a thousand response.
So it's supposed to be mandatory 1,000 responses.
Mhm.
Maybe 500 responses do not
Respond. Okay. So, okay, that is a good question. So before you play with this kind of analysis, let us, when you have a serious work, you started by understanding the questionnaire, reading the questionnaire, understand it, and you know if each question is mandatory to each and everyone. That's where you will have the idea of the survey. Then once you read the questionnaire, you understand the purpose of the survey, you come on the data. Yes, you import the data, you summarize it to see how many people has responded. Sometime when we are doing a survey, we have the targeted number we are going to contact. Or even you can also come and look at the global option there. Or you can see any rows, whatever, to see the number of observations. Yes. Now we have seen that we have 1,205 responses. You see, when you look at the global environment,
That's even the first thing you have to see.
yeah, and I think we have seen it. Like when we do summarize, you see, at the time you do summarize, I don't know where the code was. Okay, let me do it for you. It's fine. Okay, and do it for you. Summarize, summary, not summarize. Okay, and then you put the name of dataset. What else we see? This is what we are going to see when we are using summarize. REMF, that is the number of observation. I do summary, I put summary and then put the name of the data set. That is where we started. Actually. Yes. Then you get the REMF. Put the name of data set. You don't have it. This is the number of observation. That's what we call REMF. We have 1205. Yeah. And you calculated the missing value to the specific column. You have seen that in a temperature we have 57. Among 1,205 who was supposed to answer, 57 was, they didn't provide the answer. Okay. So the way we see, we use column sum. Yes. Did you heard about this formula of column sum? This one. Okay, let me check for you. This is for each and every observation. Okay, ni ukuvuga ngo aha ngaha icyo tuba dushaka kureba, turi kureba abantu bari suppose bari respondinze bangahe, ni igihumbi, ni ukuvuga ni 250. Bivuga ngo observation zose they are supposed kuba 250. Noneho iyo usanze hari aho bidahura, nko muri temperature urabona ko ari 200, muri temperature ntabwo nta kintu bavuze. Okay, it's fine, ntacyo bavuze, ariko bari suppose kubivuga. Niyo mpamvu tuhita tuvuga ngo reka tujye gucekinga iki missing value. Yego. Noneho numara gusanga zirimo, ubwo uravuga ngo ni zingahe, wenda dusanga ari 57. Yeah, that's why we handle it. Ukatekereza mini mode whatever byo tugiye gukora. So who is looking for online people? Yes, there is no problem there. Okay, so then after seeing it, we are going to see how we can remove those missing values. You have to check the percentage first of the missing value. You can take the number of missing value, divide by the total response times 100. Sometimes there is a thought said, if you see that it is above 25%, you can't rely on the findings of that variable. Yeah. When it is above 25. Yeah, because we treat the missing value for specific variable, not to the entire data set. Yeah, we need to understand variable. Yes.
If the missing value is above 25%,
yes,
is it significant that you treat that missing value by putting the mean, or you just remove the entire column, or you treat the missing
you know,
value?
if you remove the entire column, it is going to be removed to the other data set. That's why they say, I'm not like concluding it, there is some thought. But if you see that those variables was really important to your analysis, and yet above 25% of responses, you didn't receive it, you can't rely on those findings. Either you go again to ask for the people who was in charge of giving you that data. That's the only way I think you can use. But and otherwise, if it is less than 25%, it means that 75 of the people who was targeted was answering to that question. But if it is 25, it means that almost below 75 of the targeted people didn't respond to that question. Yes? Okay, but I'm not concluding. There is other who said they used to say 30%, whatever. But if you say I'm going to greet it, remember that you're going to greet it data set. But once you see that it's far below 25%, as we said, you have to think about replacing missing value by mean, either by median for the numerical columns, and for mode, yes, and for mode into on categorical variables. And when we use mean and mode, because we say on numerical we can use mean and median at the same time. But when to know I'm going to replace missing value by mean or median for numerical data. So okay, we are going to do it, but I want you to understand the logic before we do the code. Yes? Mm-hmm. Okay. So what I said when you see that those rules of 25 is okay. On the numerical data, we normally knows that when it is a numerical, we can use a mean and a median to replace the missing value. And we need to know when we use a mean and when we use median. You have heard about outliers. Yes? So if we have outliers in our data, they are devising us to replace missing value by using median. Because the median is a base estimator which cannot affected by outliers. If I say outliers, understand that we are asking let's take an example to understand the outliers. So we are asking the ages of the participant in this class. And you see like we are in a range of 25 and 30. Yet in a data, you see that there is 13, 3 years, 100. Those data which is far from others, either below or high. Yeah, far from the others. Yeah, that's what we call outliers. And if you see that there is that case in your data, that's where we say to replace the missing value, it's better to use median to minimize the biasness of the result. But if you see that it's okay in your data, there is no outlier, you replace missing value with a mean. It's 5. And for the categorical, we use a mode, highest frequency. How can we check outlier? You can use the chat code box plot. Or even you can check for the scan. Yeah, there is many ways, but the easiest way, you can also use the standard deviation as he said. So if you see that the standard deviation is higher than the mean, yes?
Depends on the size of the data.
Yeah. There are some people who used to say, if you see that the standard deviation is higher than the mean, which it means that there is outliers there. But there's others who prefer using box plot to see, because when you are using the box plot, and yet there is outliers, you will see the dot, which is maybe, can we do, because we are jumping, but it's fine. Okay, let me read it. Let's use standard deviation, we will see the box plot there.
What's standard deviation?
You don't know meaning of a standard deviation?
Somebody
Who knows the standard deviation? Can you explain to her the standard? Sorry. To him, sorry. Katowaye. To him, sorry.
Standard deviation.
Yes.
How much is that is far or close to the mean, the average? The average, yes.
For example, when you have a graph, to prevent the standard deviation on your graph to check whether you have big differences, you take your average and divide into 2, then the Excel sheet is the command where you can use Excel sheet and then you can
speak layman's language.
For us to know the variance or the deviations, like differences, average differences, because you can't know if I provide 5K, others they provide 1 million, others they provide 1,500 something. For me to understand the weight of my class, sorry, my church growers, the church growers. Sometimes standard deviation, they can help me out to put theirs into the standard differentiation, something like that. So if we say now, we get like there's some growers who pay like 5K, 10K, million, 100 million, something like that. Until maybe let's assume you have 50 members. You can't know the differences among them by tracking each and every country. That's why we have what we call variance. It is a statistical method for us to understand the variation among those kind of things. We use variance, average value. We know that there is a variance there, but on average, without looking high and low variation. Because if you take a members who pay 5K and compare to who pay 1 million, there is a high variance. But also there is one who pays 999, and those who pay 1 million, there is a small value there. But if we need to see the average variance to the entire participant, or to the entire member, that's where we consider what we call variance. Standard differences.
How do you calculate that?
You need to know the calculation.
No, for example, let's give 5,000,
Yes.
10,000,
Okay.
and then 100,000. The values of those three numbers.
That's what you need to know.
Yes.
And you know how to calculate it.
Average doesn't.
From there, can you leave it aside? Because
Okay, fine.
mathematical stuff. But you understand the logic.
Yes, I understand the logic.
If you don't, I don't want to go in calculation, but we take X minus whatever. We take single response minus average responses value. For each and every stuff, we put in square root. Sorry, we put in square for us to cancelize the negative numbers, and then we divide it by the sample, finding something. Those are the stuff we use to calculate by using the hand. But for us here in a software, we write it back, we get the answer. What I want you to understand the logic. Yeah. But to get it here, you can use value, var, something like that, and then you get it. Yes? Okay. To get it, you can use value. If I write variance is going to use then use var. And then because I need to calculate the variance of the temperature, yes? No, I put first I add the name of the data set. Then I specify. I specify by saying this is the better way you can know how to calculate
but other formulas have to run. You see, I get NA. Why? In mathematics, when we have, for us, when we have the missing value here, it's what we call infinity something. Like if we have a missing value, there is also what we call like system, they take it as an infinity. That's why I calculated the variance and then I get NA, null values, but yet in a temperature there is a response system. For us to ignore the effect of those missing values that are there, we add other formula called, we put a comma, and then remove
NA dot
remove this one equal true. For us to do not consider the missing value there into the data set.
What's enabled?
And then that's what I was explaining. Like if we have a missing value in data set, because when the logic calculations of the missing value, we take like, is there any way to write? To write the formula?
Hey, unless you, wait. Yeah, actually, in summary, this is just telling us that calculate the variance by omitting the missing values. Because when you are summing a number plus a missing value is missing. So yeah, omit them before you sum. Yes.
If I add that formula, you see that I get 171. This is what we call the variance of the temperature, average variation of the temperature. So across those things. The same thing you can do. I will try to show you the way you can calculate it. But let's come back on replacing the missing value by mean. So how can we now? I think you know the way where we can replace those stuff. Oh, yes. We need to stay. Okay. Maybe for this let's take a fine.
Practice. From now on, don't close your R. You have to dream R every day.
I'm going to do chicken fries. Select that variable, we put square bracket. Then we type it at we type is .na close and open bracket. We write this again. Then you put equal sign. You can use less than negative or equal sign, whatever you use is the same. Yes, climate underscore raw data, square bracket is NA, climate underscore temperature equals bracket and put equals square. Then you can put less than negative or equals is the same. Once you are done, yes. You don't see?
No, I'm saying I'm trying to understand the formula.
Yes. You are selecting the variables first.
Select a variable
Go there.
where is negative.
This is here. Yes, dot NM into that variable is going to be equal, mean is replaced by what? Mean. By mean. Type mean. Mean of what? Mean of this. Yes. Comma. Remember to add any dot. Remove equal to ignore that missing value. Any
It's not like
then you run. The missing value is going to be replaced by
seeing the problem.
Are you seeing or you?
No, it's not the result.
You have a problem? No. Okay. There is no problem now. So understand the logic of the formula. First, I'm interested on the climate change. Sorry, on temperature. I have to write the name of the data set, specify the column, yes. Then you have heard about this square bracket. It's like when we are using the square bracket, we are looking for specific rows into that variable. Yes, we go on these variables for each and every row that has missing values. Yes. Then replace by what? Mean of that variable, but ignoring those missing values, because we have had that if you take missing values plus numbers, you are going to get a missing value. And then you run, the missing value is going to be replaced by mean. Once you check the missing value again on the columns, you are going to get 0. Yes? The same time when you are going to replace missing value by mode, by median.
So what I'm thinking is the advanced should be out. This tier 3 should be out because it's unnecessary. This is something we can do in Python.
Yeah, sure.
We can let the person in charge of Python to be the one to work on this because it's more about forecasting.
Yeah,
It's probably
it's a nightmare.
yes, it's unnecessarily too much. So the financial modeling, this.
Using this microphone.
Oh,
We are trying to take the missing value out of the data set, replace it by mean. When we check again, if I come and check the missing value here, on the temperature I'm going to see 0, but before we was having 55, 57. If I check again, I have a 0 because I take those missing value there, I replace it by the missing value. I replace it by mean. Yes? What did you put in you say? That's good. What did you put?
Another column was missing, but it
was none. Before it was none. He was having 57 now.
What's in that position now? What is written there?
There is a mean. Yeah, we replace it by mean. So if you want to replace it by media, you have to change only for the media. And for the side of categorical stuff, if you have categorical variables, so if you have categorical variables, you have to know the way you can see the categorical. You can use a structure, or you can use, for example, you can use summary, and then you see if it's a character or numeric. But we have done it, there is no way to see it, because we know that the country it is a categorical variable. So if we need to see the mode of categorical variables, I'm going to show you the simple way, but otherwise you can develop your own function that you will see it. There is no way to deploy functions. You can use tab, for example. Tab, when you need to see the frequency of the categories, you can use tab. To use tab, you write tab, you put the name of the variable, the name of the data set, and then you specify the columns, the categorical columns. Table. Yes. It is table. When you run it, you will see that in Burundi we have 37, 50, 331. Those are the frequencies among all the categories. And from there, that's where you will see highest frequency as amount. Then you come back again to place the missing value by that highest category you have seen. That is the only way you can use when you handle the missing category. So the way to do it, it is also the same. You can copy this. The way to do it, because we don't have missing value to the country. Let's assume that we have a missing value there. So we put the country.
I don't know what that means. Okay, I see what has happened, but I don't know.
And then also what I do, I'm going to equalize with measure. So with mode, because it's categorical. I don't want to complicate it by using a function to calculate it. A simple question. So the simple way to see it, you can use now and then see the highest frequency. Use double quotation. You have heard about it when you are trying to write categorical numbers. So the categorical value. So then let's say because we have seen that the value that starts highest the number, you can come and then put that number. So from there is the mean. You take the missing value in country, you replace it by Ethiopia because Ethiopia is a country that has highest frequency. That is the way the solution elaborate those elements. So because I don't have any missing value in country, for the data set we have, there is no missing value in category. Yes, you want to see the problem. Yes, it is the same, only the difference is here. So to get this country of Ethiopia, we use tab. We put the value. When we need to see the frequency of the categorical variables. We use table function. Table puts the name of the country, and then we
So I remove the third chapter. or I can tell Claude to.
So from here,
But
we have seen how we can
it's
handle
the same thing everywhere.
So then we go
Just
to
don't
the
want
way
to
we can
speak
check
for
also
that
the
much.
Okay.
Okay.
well, okay, that your data set
We
is
talk
filled now in terms of your
Even
now,
because when you mute
the next
it,
step
it means
is
you're
check,
muting him.
check for the duplicate.
And this is what is me.
You say?
I'm saying there was a missing value and another column
Where?
mean for. Mean for her to the
You mean sorry, rainfall. So the rainfall can also be the same. Let's assume that we're going to replace it by checking. So the way also are the same. Rainfall. That's we have to use only to erase this.
Yeah.
no.
So this, and then once we check again, we are not going to see those. You see, still there is no missing. Still we have because doing the same. Yeah, for me I'm okay. For you, you can also do it. So from here we are going to see how we can check duplicate. Checking this duplicate, we check duplicate to the entire data set. We can't say that we are going to check the duplicate for the single column. We check the duplicate for the entire data set. So to check it, we use distinct. Sorry, distinct is to remove it. Okay. We use deprecated. If you use distinct, it's like to delete it. If we need to check duplicate, we use deprecated to check for the duplicate. You put the name of the data set. Yes? Deprecated. If you write deprecated, you see we are going to see false true something like that. But if you need to see like how many, you will add the function called sum. So you will add sum, and it is going to help you to see deprecated sum. Then once you run, we don't have duplicate in our data set. That's why I get 0. But let's assume you have duplicate in your data set. How are you going to treat it, those duplicate? Because the duplicate affects our result for nothing. Here is checking duplicate. Record. Then You have to run the tidyverse first because for me I didn't run. Which one? For me I didn't run it. I did it for other script, but for other markdown I didn't run it. For me to get this distinct, this one. Distinct is helping us to drop the duplicate. Let's assume that you get a duplicate in a dataset and you need to drop those duplicates. But in our dataset, we don't have it. I'm trying to show you the way you can delete it once you have it. Distinct. It's a code used to drop the duplicate in a dataset. So for now, for us, we are on the same page. Okay. Then we go now on how we can also use. Okay.
So for dropping duplicates.
Yes, that's what we are saying. Then we go on how we can use mutate, adding new variables in dataset. When we are adding new variables in a dataset, we have seen that we can use mutate and transmutate. It will depend on the way you want. So let's add the new variables first by using mutate, as you understand the logic of it. So type of, so yeah, it's fine, no need, because this is a comment. Yeah, no need. This is a comment I'm trying to write. This one. Or even I can put it above the chunk. This one, I can add it above the chunk for us to avoid that error. So by using mutate, what we do when we need to add new variables, so we type the name of dataset, because I want to add new dataset that has additional variables. That's why I'm going to create new without using the first version. Because recent previews, when we are doing data cleaning like this, sometimes you can import the dataset, and yet you see that you are going to duplicate it based on the assignment you have, and you end up with like you started by the original data set of 100 variables, and you need to do some transmutate, for example, you will end up with a clean data set of 50 variables. So that's where you will need to change the names of the data set you created. For me, I'm going to change the name of the data set, adding one, for example, for the sake of detecting the new variables I added compared to the previous one. So I started by creating a new variable that is going to be assigned with the new data set I'm going to create. So then you can use less than, minus, or equal, still at the same, because we want to use mutate. I type mutate, put the name of the data set, original data set, and then I put the comma. I write the new variable name. We are going to add rain score, for example, rain underscore score. We have seen that you can't, when you are generating the variables, you can't put the space, something like that. Use underscore, whatever for us to. This is a new, you type the new data, the data set, the original data set, the name of original data set, and then comma, you put the new name of that variable you are going to create, then put equal. It is also going to be, can we take, it's an assumption, can we take temperature plus rainfall plus humidity divided by 100 something, just for us to run. Okay. I can use this, or I can come to the column name. So I can add names for me to see how the variable it is written, because I have it here. I can come, then I take temperature plus rainfall plus humidity, something like that. So from here, once I run, and then I go to check the variables on this new data set I created, I'm going to see the additional variable called rain score, which is generated by taking a temperature plus rainfall plus humidity. If I run this, so then once I check the name of this new data set I created, this one, you will see that the rain score has already created. So if you view, if I do view, you see those are the additional variables I added by using mutate function. I'm adding a new variables based on existing. You want to see the code for mutate. So use mutate. First create the new name of the dataset we are going to add that variable, because I don't want to add on the original one. Then do mutate, open bracket, put the name of original dataset, comma, new name, like the name that variable you are creating you want to be, equal, put the name of the variable, and then put the sign. Yeah? Yeah, plus rainfall. Don't write it. Maybe you can use the name, you copy it and paste it there for you to make it easy. It's fine now. Okay. Can we go to transmutate now to see how it is? Yes? Are you understanding this one? Yes or no? Some people who used to run. Are you understanding something? Papa? Yes. Please, if you don't understand, try to ask, because if you read without understanding, I don't think when we go to the analysis, we're going to get something. Because those are the things you used to play with before doing analysis. Yeah. Okay, let's go to transmitted to see. Okay. It's not running. For you, it is not running.
Let's mutate. M-U-T-A-T.
Okay. Did you run the library code? No function code mutate, because you have to run the library code 30 parts before.
Yeah.
Yeah.
I think I run here.
Run it again, please. Let's wait to see. Okay, now run it here now. Mutate. So,
Temperature.
make sure that this is written the way it is. You can use a name. Okay, you can use like name.
The Bradford name, right?
Yeah.
I think this is it.
Can you use the name? Okay. The simplest way, you can type name and then put the name of the dataset. All variables are going to come the way it is.
Yeah, here.
Yeah, this one here. So this one, use this one, and that
Yeah,
one.
there's the names.
Okay, select it from here. The
Yes,
way
ma'am.
it is. Those, yeah.
Delete ones.
Even that quotation.
Remove the quotation.
The same to the right. Yeah. I think it's going now to work.
But I can. Let me give you one hint. If that one is. But you can. Let me show you. But if you do like this, create no, then
Even you can use this and then you delete it after. So let's use transmutate now to see. Okay. So on transmutate, the logic are the same, only the result is going to be different. Nduvuze ngo yatakaye. So are we on the same page? Let me explain the logic, because transmutate and mutate are the same, only difference are outcome. So then I want you to follow. If not, we are going to move. Okay. So what I said, because most of the time you will have to add new variables, remove whatever. So what you do, you generate maybe the new name of the dataset you are going to create, use mutate, but first make sure that you wrote the package code tidyverse. Yes? Once you wrote the package code tidyverse, write mutate, open bracket, put the name of original dataset, like the previous dataset you have. For us, we have climate underscore raw data. Then put comma, put the new name you want to generate. For us, we need to generate the new name called rain underscore. Variable called rain score. That's what I say. We need, this is a new column name. Then you add equal. That column is going to be composed by temperature, rainfall, and humidity. Then you close the bracket, you run. Those new variable is going to be added to this new dataset we created, not the original, because I didn't prefer to use the original one. But you can also prefer to continue to adding based on what you have. So transmutate, the only thing you have to change, it is only here to say transmutate. If you say transmutate, see what is going to happen. I can come and then I say transmutate. Transmute. No, transmit. Yeah, transmit. And then I said, maybe let's call it as a 2. So if we select, and then we see transmit, use transmit. That's That is the code. Like the meaning is transmitted, but okay, book. Let me see. You see, we have only one variables we generated if we use transmit on the code, but the function is called transmitted. This is the code. What you have to change only copy the code, and then where we put mutate, add transmit only. So the output is going to be the rain score only. Other variables was treated.
So besides the variable we need to read
On transmitted, we said we generate new variable based on existing, and the output that is going to be displayed, it is only what we generated. Others are going to be treated. Yeah. Even those who didn't those variables you didn't consider are going to be treated.
Transmitted. Parameter.
Which error? You didn't run the library code tidyver. Okay. Have you run it first? Okay. Control enter.
This one.
So select this and then run to select. Selecting.
Selecting yes. Control enter.
Yeah. This is transmit. This one.
Transmute.
Yeah, not transmitted. If you run, you're going to get answer.
No, this is what I'm getting.
What are you getting? This is what you have. Okay, then kugira ngo ubone result, copy this and paste it here. See, iyo bataguhaye error, it means that it's fine. See, urabona ko result zije,
ariko agomba kuza rimwe ariko kuri transmitted nashaka kuri transmitted.
Remi duhindure izina. Nuko iri zina rya mbere yari yabikoze, urebye kuri row 1 irahita iza yongeyeho ya reni. So from there, let's do rename and then we are done. Yeah. We do transmitted distinct. We remain with grouping. Okay. So let's do now. The last one is what we call. Let's do rename to see. So renaming the variables. Sometimes we will receive the data set that has complicated variable name, and you need to clean it, export it in Excel with a clean it version, something like that. So you will need to rename it. All those things we are doing, it's like manipulating our data to be able to have it to the standard we want it, for us to share it maybe for the analysis or starting doing analysis. Because sometime in a real world, you will see that there is some team who are responsible for doing data cleaning, and there is others who are responsible for doing analysis, and also the others who are responsible for doing reporting. So for us, things related to the cleaning here. So to rename, or let's say we need, let's say we generated a new variable called rain score, and then maybe during the generation of this variable, we say it as a rain score, but yet was average rain, for example. We call the name which is not correct. We want to rename it as average rain. What can we do? So the logic are the same. So we write the name of the dataset where the variable it is located. It is located on climate 2 for me. Is there anyone who has a problem? Where? This one? Yeah. Can you check for online? Let me check. What you say transmit, not transmitted. All are the same, both formatted and transmitted. Just understand the logic. Sometimes doesn't mean that when we are doing analysis, those steps we are going to go through it. Doesn't mean every step you are going to go through it. For you, you have the data, look at it, understand it, and see what you need to do for you to have the proper data. That is the only way to play with the data set. Because sometimes we will see that it is cleaned. What is needed maybe without cleaning because it is cleaned. So now we are going to rename. So doing rename, what we do, write the name of dataset equal, then write to rename. The rename is going to come, put the name of dataset, comma, new variable, new name, like average rain. I want to add to say average rain is equal to the old. Can use this one. Even I have to select this one, rain score. Once I'm done with this, I have also to deal with this one. So I'm done. Once I'm done, when I check this variable, is there anyone who has a problem online? Can you check? You see, when I check, I will.
Average rain is equal to
Please, I want you to understand the procedures. Other things are the same because mutate, transmutate, average, arrange, whatever. The methodology are the same. So what you need to understand that you started by putting the form, like the functions or the codes. If it is mutate, do equal, mutate. If it is transmutate, whatever. If we come on arrange, make sure that we write the name because we are trying to rename the variables. Put the original dataset where the variables you want to rename, the dataset is located. Because I want the variables located on climate 2 as my dataset, I write the name of dataset. I put a comma. Here, this is the new name I want to assign to that variable I'm interested to look for. And this is the old name. Yes?
getting an error here.
Why are you getting an error? Because to get an error, it's to don't understand what you are going to do. That's what it means. Yeah, sure. Because this is a simple stuff, for sure. Yeah, you see, maybe let's add. Let me do something like that for you to understand it. Name of dataset is put a comma, new name equal or no, don't write this one. I'm trying to, yeah, don't write this one, please. You see, I'm trying to guide you when you are using mutate and transmutate. So you type the new name of the dataset you are going to create or the existing. You add the function like mutate, transmutate to rename, name of a dataset where the variable is located. You put a comma. That's why we write the climate raw data too, because our variable we are looking for, it's called rain score, and it is located on this dataset. I put the comma, I add the new name, which new variable name I want to put there. So because we before we have it as rain score, and
Instead of calling it rain score, let's have it as average rain. That's why I add the new variable here as average rain. When you check again the data set, the name is going to change as average rain. The same case, next.
So if they have climate row two twice, then like the data set name and the variable the data set they are creating,
Yeah,
they
it is
have
off.
similar name.
I think
That's
batteries.
one similar name. The reason why, because I don't want to duplicate another variable. So another data set.
So that data frame that is within the function beneath, is it related to another data set or is it related to this particular?
it is related to raw climate too.
Create another one.
So let me go here. So what I did, I created, yes, I created as single data set that has one variable, and I call it climate row 2. Yes, when you print it, I print it and I get rain score into that data set. I said instead of having rain score, let's have it as rain. Once I run, still I replaced what I already have. Yeah, that's what I. Okay. Yes. Mm-hmm.
We have climate row two.
Yes.
Data set at your cursor, it's all like the data set we are going to create.
Yes.
And the data set
The old we was having.
had similar names. The one
Yeah.
that
Yes. There is no problem here because I do this because sometimes you may find that there is no need to create more of data set in analysis. You need to do it once and then you are done. So, and you see these kind of things we do, we are going to use pipe function, sorry, pipe function for us to do it in a single line. Like I can go in a data set, I check for the missing value, I replace it with a mean, I add the new variables, I rename it as the way I want. Those processes in a single line by using a pipe. That's what we are going to do, and then we close.
Today.
Yeah, today. This is a, I think you know it. You know it. Maybe let me practice it. We are going to enjoy. So, okay. From here, we are okay. Even for arrange, you specify which variable you want to be like, the first one, whatever, still are the same. But make sure that you load tidyverse. That is a key. If you don't load the tidyverse, the formulas are not going to work. Yes? So come back to the pipe I was saying. You can go on climate data. You see, I can go on climate data. Did you see something like that? Let me show you this one. Pipe, is it shift control M? Something like which shortcut to add pipe? Is it? Yes.
Oh, shift with
Something like that. Control Shift M. I want you to explain the logic of using this kind of thing because it's helping us to simplify the writing. It is called pipe. Pipe. This one where that I'm selecting. This kind of thing. It's called pipe.
control.
Control Shift M. Yeah. The importance of using pipe. The that's one. Control Shift M. M. It is not coming. Control.
Wait, let me see.
Okay. Have you done, or you still have a problem? Okay. Okay. So I want you to use pipe to combine those kind of things we have had. Can I scroll up? Okay. So you have seen that the importance of using pipe. Please follow. So can you follow, please? Please, can you follow? Because I want you to tell you the importance of, yeah. So I want you to tell you the importance of using pipe. Because you have heard that we started by exploring the data set, going into the data set, we do summarize, we get summary statistic, we jump to the checking missing value, we go to the replacing missing value. After making replacing missing value, we do rename, we do transmutate, we do arrange, and then we do summary statistic or tabulation. When you see what we have done at this afternoon, when we are using pipe, it's like go on single variable, apply all those steps at once. No need to create additional data set, whatever, something like that. It's like someone told you that go on Nyabugogo, find something. If you find it, go where, something like that. That is like it is simplifying repetition of the coding. So when we are using a pipe, I want you to show you the simple way. If I say, go on the data set called climate row, summarize. Summarize. After summarizing it, do what? Duplicated. Something like that. If I do this, you see false. No duplicate. That's what it means. But from here, you can say some. When we are doing when we are checking the duplicate, we normally write deprecated bracket name of the dataset. Because we are using a pipe, there is no way to write again the name of the dataset. Because if we are using a pipe, everything that we are using, we are dealing with, it is referring on this dataset we started using. And from here you can continue. You see, zero error. What happened? Okay, this one I can also do something like that. What else we can do is that any column, maybe can do column sum. Is it going to work? Is that any something like that? So let us run, then we see. Can I? Okay, someone else this one. Let me do this to see. Still X. Where?
No, 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 no. That's it.
Yes.
Is any before and then it pipe it to the phone.
Ah, okay. This one
Yeah.
is dot n dot again pipe it. Core sum. I was guessing like if I type in column sum, this, yeah. And from here I can also specify the specific variables to rename it or to do something. Let me see. Two dimension, what does it mean? So the end result, it's like we need to combine all those kind of things we have had. Like the importance of using pipe, you can start by looking for the data set, summarize it. At the first time, once you summarize it, continue to check for the duplicate. Once you check for the duplicate, you can also remove it. If no, you can also replace a missing value, something like that. Like take a look of all the processes we have had at this afternoon. You can use a pipeline to write it as single line, something like that. That's what we are trying to do. Let me do this one. Yeah. You see what we did? For the first time, we said column sum, put the is dot na, the name of the dataset. You see what we did first? We started by saying that we have to code the column sum bracket is dot na, and then we put the name of the dataset. But from here, you can use the name of the dataset, then use the pipe is dot na. Once you are done with checking with is dot na, you can also summarize it. And from here, you can add whatever kind of things you want. That's what I think. Yeah. Yes.
So the essence of that part there is not to always call the data along with the function that you want to perform on that data.
Yes.
Like for instance, if we are doing .na, you first say that climate of raw, in parentheses, you put is.na, the will in that function except the column that you want to check for. Not the, I mean, raw value.
Yes.
So because of this part now, making this in that once the climate raw, the data is there, and then once you put the pipe to a sum,
Yes, color sum.
function to that data.
Yes, it is going to come to check where it is stopped and proceed with it until to the final stage. Yeah, that is the easiest way to simplify all those processes when you are doing the analysis. Because sometimes we see that you are doing things which is repetitive. So I think we can close by here unless if you have a problem.
Questions are there, but next time.
Okay, thank you. So I think there is no question we can cross.
Hello, good evening.